This is a general aptitude question. It is said that 10 friends have planned to equally share the cost of a gift for their teacher. So let us assume that each student contributes X rupees. Then the total amount contributed by all of them will be, which will also be the price of the gift, that will be 10 times of X. Now they are saying when two of them decided not to contribute, then each of the other friends had to pay rupees 150 more. Now out of these 10, two people are not contributing. So we have 8 contributors, and each of them, which were earlier paying only X rupees, now they are having to pay 150 more. So now each of these 8 friends will contribute X plus 150 rupees, and that will be equal as the price of the gift, which means we can write 8 times of X plus 150 equal to 10X. Now we shall solve this. 8X plus 120 and 10, 1200 equal to 10X. So we get 2X equal to 1200. So value of X is 600, which means earlier when 10 students had decided to contribute, that at that time each of them had to pay rupees 600. But now since only 8 people are contributing, then each of them will pay 600 plus 150, which is 750 rupees. They are asking us the cost of the gift was rupees how much. So we have two ways to calculate the cost of the gift. Either we can do 10x or we can do 8 times x plus 150. Both will give the same result, which will be 10 times of 600 equal to 6,000 rupees. From here also we can get 8 times of 750, which is also 6,000 rupees. So that is the price of the gift. Option C. This is a simple reasoning based question. They have given a fill in the blank type of sentence and we need to find the appropriate choice for this blank. The expenditure on the project dash as follows, and after that they have given 3 different divisions: equipments, salaries and contingency. So what is basically they are meaning to say is there is an expenditure allotted for the project, which is then divided among 3 factors, which is equipment, salaries and contingency. So in this blank, we want to fit a sentence which is on the similar lines as divides, because this entire expenditure is being divided among these 3 factors. So looking at the options, we see that breaks down is the most appropriate choice, because the expenditure on the project breaks down as follows is in similar meaning that it divides into these following factors. So the correct option will be C, breaks down. This is a general aptitude question. A search engine's business model dash around the fulcrum of trust. We need to find the most appropriate word fitting into this blank. The sentence is on the lines of that the search engine's business model is dependent around the fulcrum of trust, which means if there is trust, then the business model will survive. So in this blank, we need to find a word suitable in the sense of dependence, because the model is dependent upon the trust factor. So among the given options, we can see that the revolves is one such word, which is in the similar sense such as dependence, and the search engine's business model revolves around the fulcrum of trust makes complete sense. So the appropriate choice here will be option A, revolves. This is a general aptitude question. They have said that 2 cars start at the same time from the same location and go in the same direction. So let us assume those 2 cars to be C1 and C2, going in the same direction and starting at the same point. The speed of the first car is 50 km per hour. So speed of C1 will be 50 km per hour and the speed of second car is 60 kmph. Now they are saying the number of hours it takes for the distance between the 2 cars to be 20 km will be. So we know that the formula for distance is speed into time. Hence for this car 1, the distance covered with respect to time will be its speed, that is 50 into time. The unit of speed given over here is kilometer per hour. Hence we take the unit of time t to be in hours, so that the distance covered will be in kilometers. Similarly for the car C2, the distance covered will be 60 into t kilometers. We want the distance between them to be reduced to 20 kilometers. Definitely this car 2 will be ahead of car 1 since its speed is higher. So we shall do 60t minus 50t, which is the distance between them at time t, and that should be equal to 20 kilometers. Solving this equation, we get 10t equal to 20, which means t equal to 2, which means after after 2 hours, the car 2 will be 20 kilometers ahead of car 1. Hence, after 2 hours, the distance between these two cars will become 20 kilometers. So that is the answer, option B. This is an analogy based question. A court is to judge as dash is to a teacher. Now we know that a judge works in the court, that is his workplace. In the similar sense, in this particular blank, we need to fill the workplace of a teacher. Now we know that a teacher works in the school, so the analogy goes as court is to judge as a school is to a teacher. Hence, the most appropriate choice for this blank would be option D, is school. This is a set theory question which we can solve by making the Venn diagrams. We have 3 student clubs which are drama club, dance club and the maths club. So we make the following Venn diagram with intersection of all the 3 clubs because students may belong to one or more of them. Let us call this one as dance club, drama club and the last one as maths club. Now they are saying 60 students are only in the drama club, which means they belong to this particular region. They belong only to the drama club and to no other club. 80 students are only in the dance club. So over here, 30 students are only in the maths club. So they belong to this particular region. Now they are saying 40 students are in both drama and dance clubs. Now here they have not used the word only, which means out of these 40 students, there may also be some which are belonging to all the 3 clubs. So we assume here we have X, which means the students belonging to all the 3 clubs. So out of these 40, there will also be some which belong to this particular region, and this is talking about drama and the dance club. So whatever the students will be having in this particular region, out of them, some may also belong to all the 3 clubs. Hence, these 40 minus X will be the number of students who belong only to these 2 clubs and not to all the 3. Hence, we write 40 minus X, and in the same way, 12 students are both in dance and maths. So here we are going to write 12 minus X because they must belong only to these 2 and not all the 3. Similarly, 7 belong both to drama and maths. So here we write 7 minus X. And now they are finally saying 2 students are in all the 3 clubs, which means the value of X we have taken is actually 2. Hence this becomes now 38, 5 and 10. In total, 38 students are there only in the dance and drama club and not 40, because 40 will also include these 2 which are belonging to all the 3. If I'm saying that I belong to all the 3 clubs, then I will definitely belong to dance and drama club. Hence they had included it over here without using the word only. So now finally they are saying if 75% of the students in college are not in any of these clubs, then the total number of students in college will be. So now we get the fact that whatever students are present in this particular Venn diagram make up only the 25% of the college strength. So let us add this up and see what is the strength we are getting. 80 plus 60 plus 30 plus 38, 10, 5 and 2. So we get 80 and 30, 170 plus 40 plus 15, which will be 225. Now this was only the 25% strength of the college, hence the total strength will be 4 times of this. So 225 into 4 is 900. So in total there are 900 students in the entire college. Some of them belong to the clubs and some of them do not. So the answer we get for this question is option C, 900. This is an aptitude based question. The police has arrested 4 criminals, or we can say suspects, P, Q, R and S. They all knew each other and they made the following statements. We have to assume that there is only one criminal and only one of these statements made above is true, which means at a time only one of them will speak the truth and all the other 3 will not speak the truth. So we will take contradiction of the statements which they have made. So we need to identify who has committed the crime, means who is the actual criminal. So for this, let us first assume that what P is saying is true and all others are not speaking the truth. So we shall take contradiction of the statements made by these three. So let us see what P is saying. Q committed the crime. So for the time being, we will assume that Q is the criminal. And now let us see if other three statements support this claim or not. We shall take the negation of all the three statements because they are not speaking the truth as per our assumption. Q is saying S committed the crime. Its negation would be S has not committed the crime. So yes, that supports our claim. R says I did not do it. Its negation, I did it. So now we got two criminals, both Q and R, but there cannot be two criminals. We got a contradiction over here, which means P is not speaking the truth. Our assumption is false in this case. So now we shall go at Q and we'll assume this time that Q is speaking the truth and the other three are not speaking the truth. So we shall take negation of other three statements now. Q saying that S committed the crime. So now we shall assume that S is the criminal and we shall see that other statements are supporting it or not. P says Q committed the crime. Negation, Q has not committed the crime. Yes, that supports our claim. R says I did not do it. Again its negation becomes I did it. So now we got again two criminals, R and S. But there cannot be two. So our assumption failed over here again due to R. So even Q is not speaking the truth. Now we shall come to R and assume that R is speaking the truth, others are not. So R says I did not do it, which means this time we will assume that R is not the criminal, so that he speaks the truth this time. We assume the statement to be correct. R is not the criminal. Okay, now let us see if others are supporting it. All others have to be speaking false this time, so we shall take the negation. Q committed the crime. So we shall assume Q did not commit the crime. S committed the crime. Again we shall falsify it. S did not commit the crime. What Q said about me is false. Again this has to be incorrect. We shall take the negation. So that means what Q said about me is true, but what Q had said, S committed the crime. So here we got that none of them is a criminal. So again this claim would not be true and we shall go for the final case in which what S says will be the truth. So it is saying what Q said about me is false. What Q had said that S committed the crime. This has to be false, means S did not commit the crime. And others P and R have to be saying false statements. So let us see Q committed the crime. Negation will be Q did not commit the crime. So yes, that satisfies this. R says I did not do it. Its negation will be I did it. So this claim is trying to say that R has committed the crime and what we are assumed that S has not committed the crime. So yes, these two can go along and we can come to a conclusion that R has to be the actual criminal for this case. So what S is saying is true and based upon that we come to the conclusion that R is the actual criminal. So the correct answer is option B. This is a passage based question. We have been given this small passage and we have to understand that to determine which of the following inferences can be drawn from it. Let us have a look at the passage. A recent High Court judgment has sought to dispel the idea of begging as a disease, which means the recent judgment was passed which is giving an idea that we should dispel, which means discontinue considering begging as a disease. We should no more regard begging to be a disease. Then what should we do? Which leads to its stigmatization and criminalization. If we consider begging to be a disease, then that leads to the negative impression getting created in the minds of the people. They stigmatize it and they see begging to be a sort of criminal activity. So instead of this, we should regard it as a symptom, which means we should consider begging to be just a symptom of something else. Begging is not a disease in itself. So what is it a symptom of? The underlying disease is the failure of the state to protect citizens who fall through the social security net, which means there is a disease or which means there is something lacking on the part of the state or on the part of the government, due to which the citizens are not getting enough facilities and the social welfare schemes they deserve, and that is the reason why beggars are getting created. So now let's have a look at the inferences which can be actually drawn. Beggars are lazy people who beg because they are unwilling to work. This statement is in no way being claimed from the given passage, so that is false. Beggars are created because of lack of social welfare schemes. The passage is stating that there is some lack on the part of the government, failure of the state, due to which this disease is causing the symptoms and showing up in the form of beggars getting created. So we can say that this can be inferred from the passage. And next one is begging is an offense and that has to be dealt with firmly. Again, the statement is not being claimed in any way from this given passage. That is also false. Begging has to be banned because it adversely affects the welfare of the state. No, instead, what is being stated in the passage is that there is some failure on the part of the state or the government because of which the beggars are getting created. So that is a contradictory statement which is not getting inferred. So the only correct choice is option B, which means beggars are created because of the lack of social welfare schemes. That can be correctly inferred from this passage. This is a spatial aptitude kind of question. We have been given that 3 out of 5 students allocated to a hostel have put in special requests to the warden. We have been given these 4 floor plans showing the vacant rooms, in which this gray region denotes that the rooms are already occupied, and this empty region suggests that the room is empty, so those could be allocated to these 3 students. Now they have made these special requests mentioned over here, so we need to determine what will be the appropriate accommodation provided to all these 3 students. So let us look at each request one by one, and according to that let us eliminate the options which may not be suitable for the same. The request made by student X was, due to pollen energy, I want to avoid a wing next to the garden. So we can see that in the option C, X is allocated room next to the garden. So this option will be eliminated. None other option can violates this rule, so they will not be eliminated. And now looking at the request made by student Y, I want to live as far from the washrooms as possible since I'm very sensitive to smell. Now in any of these cases, Y is not allocated a room near the washroom, so none of the option gets eliminated due to this. Finally, we look at the request made by student Z, who says that I believe in Vastu and so I want to stay in the southwest wing. Now the directions have been shown over here. This is the south and west. Hence this lower portion denotes the southwest wing and that has to be allocated to student Z. You can see that such an allocation is made only over here. All the 3 properties are being satisfied. X is not there next to the garden, Y is far from the washroom, and Z is allocated in the southwest zone. So option D will be the most appropriate allocation made to these 3 students. So that is the answer. This is an aptitude based question. We have been given a Venn-like diagram in which the triangle represents the teachers, rectangle represents administrators, and this circle represents the researchers. We need to determine out of the total number of people represented in this diagram, what is the percentage of administrators. Now we can see that this rectangle is representing the administrators, out of which these are the 20 people who are only administrators. These 10 people are both administrator as well as teacher. So if they ask us for administrator, we shall definitely count them as well. These 20 people are both administrator as well as researchers. So again, these 20 will also be counted to be administrators. So in total, we have 50 administrators, and the total number of people we are having is the sum of all the numbers appearing in this diagram, which is 70 plus 10 plus 20, 20 and 40. So this sums up to give us 160. Now to determine the percentage of administrators, we shall do 50 on 160 into 100. So this evaluates to 31.25. And now we can see that from the given ranges, this falls into 31 to 45 range. So we shall report this to be the answer, 31 to 45. So option C.
If L is a regular language over epsilon equals a comma b, which one of the following languages is not regular? And 4 options have been given here. So this is a question from theory of computation regarding regular languages. We need to take a look at all of these options and find out which among these is not regular language. So first of all, take a look at option C. Prefix of L equal to set of all elements x belong to epsilon star such that there exists y belonging to epsilon star such that xy belongs to L. So this is the prefix language of L, which means that if L contains a string, let us say ABC, then the prefix will be epsilon A, AB, and ABC. This will be the prefix strings. So prefix of, if ABC is belonging to L, then the prefix of L will contain epsilon A, AB, ABC as well. This language is regular because if we have L as a regular language, we know L will have a deterministic finite automata corresponding to that language. Now in that deterministic finite automata, for which all states that can reach an accepting state, if we make those states also accepting, we will get this language, that is a prefix language. For example, let us say we have a DFA with states like this, and let's say this is a dead state example, and these may have their protection. So it means that if it reaches this state, the DFA will reject that language. From this state or this state, we can go to the accepting state. This is the accepting state. If we have a DFA for L, language L like this, if we make this state and this state also the accepting state, then this language will be the prefix language of L, prefix of L. So this way we can show that prefix L is a regular language because we have a DFA for it. So this is regular. Now if you look at A, that is suffix of L, that is y belong to epsilon star such that xy belongs to L. Now suffix of L will be, if we have a language ABC, then the suffix will be epsilon C, BC and ABC. Now this is also just exactly the same way like the prefix language. How we will construct the DFA for this will be, for a language L, if we know that the reverse of the language will also be regular. If L is regular, L reverse will also be regular, meaning for L reverse also we can construct the DFA in this way. And in L reverse language, if we just take the prefix, that will be the suffix in language L. See, if ABC belongs to language L, then CBA will belongs to language L reverse. This one's prefix will be CB and CBA in reverse form, right? So we just take this string, and if we take the reverse form, we will be getting these strings C, BC and ABC, just reverse of these. So just we can take the DFA for the reverse language and then do this procedure, and then take the reverse of those strings, we will get the suffix of these strings as well. So this language is also regular suffix. Now take a look at option D, L concatenated with L reverse. Now L is a regular language, we know. L reverse will also be a regular language because reverse of a regular language is regular only. And L concatenated with another regular language will be a regular language. Regular languages are closed under concatenation. So L concatenated with L reverse will also be a regular language. Now coming to option B, that's only one left. Option B is not a regular language. Option B, set of all strings such that W reverse belongs to the language L. Now this string is not regular because in order to find out this language, we need to keep on checking till the midpoint of the string, and then from the midpoint we need to keep on checking whether what we got was same as what we got initially in the reverse order. Now for checking that, we will need an infinite amount of memory and we will need a stack. So this is a context free language actually, this is not a regular language. So option B is the right answer for a question. They were asking which of the following is not regular. You need to understand that the language W reverse and L concatenated with L reverse is not the same language, this is a different language. B is the right answer here. The chip select logic for a certain DRAM chip in a memory system design is shown below. Assume that the memory system has 16 address lines denoted by A15 to A0. What is the range of the addresses in hexadecimal of the memory system that can get enabled by the chip select signal? So this is a question coming from digital logic section. In the question they have given us that we have a particular signal called chip select which is given here, and this chip select signal is getting generated by this particular AND gate. Okay, to this AND gate we are giving the signals A15, 14, 13, 12, 11 as input, and see this memory system has 16 address lines denoted by A15 to A0. So from A15 to A0 we have 16 address lines which I have denoted here, 15, 14, 13, 12, 11 up to A0 here, and among these 5 of these, A15, A14, 13, 12 and 11 is being input to this AND gate. Now whenever CS signal is 1, it will be enabled, and they are asking for which all addresses the signal will be enabled. Now for the signal to be enabled, all the inputs should be 1. See, this is an AND gate, so an AND gate will be having an output 1 if all the input is 1. So if you look here, signals A15, A14 and A11 are being input in the true form to the AND gate, which means that A15, A14 and A11 should be 1, and also A13 and A12 is being input in the complement form here, which means that A13 and A12 should be 0, which will make the complement 1, and only then the input to the AND gate will be 1 in that case. So which means that A15, A14 and A11 should be 1, and A13 and A12 should be 0. They should be 0 because the complement of that is being given as the input to the AND gate. So when A15, 14, 13, 12, 11 takes the form 1, 1, 0, 0, 1, only in that case the AND gate will be enabled and the signal CS will be 1. Now for the signal CS to be 1, A15 to 11 should take these values only, and A10 to A0 can take any value. Whatever value A10 to A0 take, that doesn't matter because we are not giving it as input to the AND gate. Input to the AND gate is only A15 to A11. So A15 to A11 we have to keep it constant at this value. A10 to A0 can take any value. Now among that, the smallest value will be when A10 to A0 is all zeros, and the largest value will be when A10 to A0 is all in 1 forms. So whatever value comes in between, for all that the SIP signal will still be active. So we will be keeping this in 11001, and when A10 to A0 is all zeros, we will see what the address will be. The address will be in hexadecimal, right? So we take 4 bits, we couple together and find out the hexadecimal digits. So initially it is 1100, that will be C. When it is all zeros, A10 to A0 is all 0, the next digit will be 1000. 1000 is 8. After that all zeros will be 0, 0 only. So this is the lowest address for which the SIP signal will be active, and the largest address will be, we keep 11001 same, so this is C. The rest is 1111, that is F, and the next 8 will be all ones, that is FF. So this signal is CFFF. So the largest address is CFFF. So the range of the address is from C800 to CFFF, that is given in option B. Limit x tend to 3 x power 4 minus 81 by 2x square minus 5x minus 3. Options A 1, B limit does not exist, C 53 by 12, D 108 by 7. So this is a question from engineering mathematics regarding limits. So we need to find out what limit x tend to 3 the given expression would be. So this is a very easy question. I'll show you how to solve it. First we'll try substituting x equal to 3 into this expression here. We'll get 3 power 4 minus 81 by 2 into 3 square minus 5 into 3 minus 3. That will be 81 minus 81 by 18 minus 15 minus 3, or equal to 0 by 0. Now we got 0 by 0 form when we are substituting x equal to 3 directly here. Now since we got 0 by 0 form, we can now apply L'Hospital's rule. What L'Hospital's rule states is that limit x tend to c f of x by g of x will be equal to limit x tend to c f dash x by g dash x. F dash x and g dash x are derivatives of f of x and g of x respectively. This we can apply when if f of x by g of x is in 0 by 0 or infinity by infinity form. So this was 0 by 0 form here, so I am applying this here, meaning I am taking the derivative of numerator as well as denominator. Numerator's derivative will be x power 4 minus 81's derivative, that is 4x cube. 81's derivative is 0. 2x square's derivative is 4x. 5x derivative is 5 only. So that expression now becomes limit x tend to 3 4x cube by 4x minus 5. Again we substitute x equal to 3 here, we will get 4 into 3 cube by 4 into 3 minus 5, that is 108 by 7. Now this is not in 0 by 0 or infinity by infinity form, this is the real number, this is the limit. So the answer is 108 by 7, or option D. Which of the following protocol pairs can be used to send and retrieve emails in that order? 4 options are given here. So this is a question from computer networks regarding emailing protocols. So we are using 4 protocols here in the options. One is SMTP or simple mail transfer protocol. Now SMTP is used for sending mails. POP3, that is post office protocol, that is used for retrieving emails. IMAP is internet message access protocol. Now this is also used for retrieving emails. The difference between IMAP and POP3 is that POP3 will download the email to your workstation, whereas using IMAP you can check it on the server itself. There is no need to download it to workstation if you are using IMAP. So POP3 and IMAP both are used to retrieve emails. Now MIME is multi-purpose internet mail extension protocol. Now this is just an extension to SMTP that is used to convert non-text characters to text characters and vice versa, etc. This is mainly used for sending media files such as audio, video, etc. So this we can't use MIME alone to send emails. This is just an extension to SMTP. SMTP is the protocol we are using to send emails. Now looking at the options, you will see option B is the only correct one. SMTP is used to send, POP3 is used to retrieve emails. B is the right answer here. Which of the following statements is not correct about B plus tree data structure used for creating an index of a relational database table? A. Each leaf node has a pointer to the next leaf node. Option B. Non-leaf nodes have pointers to data records. C. B plus tree is a height balanced tree. And D. Key values in each node are kept in a sorted order. Now in the question they are asking us about B plus tree data structure. This is from DBMS section. So to learn more about B plus tree data structure, please refer to the video lectures on the topic for the same. Now here I will give a brief summary of B plus trees. Now B plus trees are used for indexing in database records. So B plus trees are height balanced trees which contains nodes in this manner. So for each internal node will have key value pairs where the value will be pointers to internal nodes only, and in leaf nodes they will also contain key value pairs, but here the value of each key would be pointers to data records. Additionally, each leaf node will also have a pointer to the next leaf node that is used for sweeping the entire data once or range queries, etc. Now based on the information we can look at the options. Each leaf node has a pointer to the next leaf node, that is true. Option C, B plus tree is height balanced tree, is also true. Option D, key values in each node are kept in sorted order, that's also true. For searching we have to keep the key values in a sorted order in each node. D is also true. So the only wrong one here is option B, non-leaf nodes have pointers to data records, that is false. Only leaf nodes have pointers to data records, like this coming from leaf nodes. Non-leaf node will have pointers only to additional internal nodes only. So option B is the only statement that is not correct. So the right answer is option B. Consider the following C program. Hash include stdio.h int main int array equal to 1 2 3 4 5 6 7 8 9 0 1 2 5 comma star ip equal to array plus 4 printf percentage d ip of 1 return 0. The number that will be displayed on execution of program is dash. So this is a very simple question coming from C programming section. We have been given this particular program. So in the program they are declaring this array ARR that is given like this. It contains 13 elements. So 1 2 3 4 5 6 7 8 9 0 1 2 5. So the array looks like this. Now the variable ARR, that will be a pointer to the first element in the array. So ARR will be pointing to this part. Now we are creating another integer pointer IP. Now IP will be ARR plus 4. Now when we are doing an operation like this, IP is a pointer, array is also a pointer, ARR. Now we are increasing that pointer's value by 4, which means ARR is pointing here. So ARR plus 1 will be a pointer to this location, plus 2 will be a pointer to this location, 3 4. So array plus 4 will be a pointer to this location. Now IP will be same as this, meaning IP is pointing to the start of this array at this point. Now IP of 0 will display 5, IP of 1 will display 6, IP of 2 will display 7, etc. Here we are printing IP of 1, that is, this is IP of 0, this IP of 1, that is 6. So the output of this program will be 6. A certain processor uses a fully associative cache of size 16 KB. The cache block size is 16 bytes. Assume that the main memory is byte addressable and uses a 32-bit address. How many bits are required for the tag and the index fields respectively in the address generated by the processor? So this is a question coming from computer organization topic regarding fully associative caches. So various types of caches are direct, set associative or fully associative caches. To learn more about those, please refer to the video lecture so that you will understand all of their properties and also how to solve questions on them. So for this question they are asking us fully associative cache. So for fully associative cache, the cache block will look like this. Here in the question they were given that the cache size is 16 KB. 16 KB is 2 power 14. So the address of the cache will be taking 14 bits. In that 14 bits, the initial part will be block offset, that is reserved for the block size. Now the block size is 16 byte, that is, if it is byte addressable, we will be needing 4 bits for that. So the block offset part will be taking 4 bits. So this is how a fully associative cache looks. Now coming to the physical address, here the total address bits will be 32. That was given in the question. Physical address uses 32-bit addresses. Now the entire part will be 32. Same block offset will be reserved in the physical address as well. So the block offset will take 4 bits. Now the rest of the part will be the tag bit in fully associative caches. So the rest of the part would be 32 minus 4, that is 28. So tag bits will be taking 28 here. Now coming to the index field. In fully associative caches, we don't have any index field. The size of the index field would be 0. Why the case is that if we have a direct or set associative cache like this, in direct or set associative cache, the entire cache will be divided into particular sets, and for given one address, if one address is given, that address will belong to exactly one of these sets only, which is called as the index in the cache. But in a fully associative cache, we are not dividing it into any sets, that for any given address, that block can belong to any place inside the cache. We don't have any index like this, which means that the index field will be taking 0 bits in fully associative cache. So the index field will be 0. The answer is 28, 0. We were given 4 options here. So looking at option A, that is the right answer. Consider the following 2 statements about database transaction schedules. 1. Strict two-phase locking protocol generates conflict serializable schedules that are also recoverable. 2. Timestamp ordering concurrency control protocol with Thomas Wright rule can generate view serializable schedules that are not conflict serializable. Which of the following statements is or are true? 4 options are given. So this is a question regarding concurrency control protocols in database management systems. They are asking us about strict two-phase locking protocol and also timestamp ordering protocol with Thomas Wright rule. Now in strict two-phase locking protocol, what we do is that we will be holding all exclusive lock until the transaction commits, which means that all the schedules generated would be strict schedules. So statement 1 is correct. Statement 2, timestamp ordering concurrency control protocol with Thomas Wright rule. So Thomas Wright rule is a modification on the timestamp ordering protocol. What it does is, it will be using Thomas Wright rule, we can ignore some write-write conflicts in our schedule, which means that it will generate schedules which are view serializable but are not conflict serializable because of some write-write conflicts. So statement 2 is also correct. So looking at options, both 1 and 2 is right. Option A is the right answer. To learn more about these 2 protocols, please refer to the video lecture. The section is concurrency control protocols. Consider the grammar below. S gives A gives B gives B or epsilon, D gives D or epsilon. Let A, B, D and dollar be indexed as follows. A has index 3, B is 2, D is 1 and dollar has index 0. Compute the follow set of non-terminal B and write the index values for the symbols in the follow set in the descending order. So this is a question from compiler design regarding first and follow. If you don't know what first and follow sets for a grammar is, please refer to the video lectures to learn more about those. Now for this grammar, we'll calculate the first and follow sets. Now first of S will be, we'll take first of B. First of B will be B or epsilon. That is given here, B comma epsilon. First of D will also be D comma epsilon. Now first of A will be equal to first of whatever we see here, that is first of B that is B epsilon. Now since epsilon is there, we will be doing first of D as well. Now D will be D comma epsilon. So the first of A will be B D epsilon, and first of S will be first of A, that is B D epsilon, and since epsilon is there, we will be adding A as well there, that is first of whatever is after A. So first of S will be B D A. Now we will calculate follow of D. We'll take follow of S first. Follow of S will always contain the dollar symbol, because whatever follows after the start symbol will be only that final symbol, the dollar symbol. No, the dollar symbol will always be there. So follow of S will always contain dollar. S doesn't appear anytime in the right hand side. So that is the only symbol in the follow set of S. Now we will look at follow of A. If you take a look, A appears on the right hand side, and after A we only have this terminal symbol A. So follow of A will only have the terminal A. Follow of B we will calculate now. After B we are seeing D. So follow of B will contain first of D. First of D was D epsilon. Now epsilon won't be there in follow set. Okay, so it will be D, and since epsilon came up here, follow of B will also contain follow of A, whatever is in follow of A. Now follow of A had A, so B will contain D comma A as in the follow set. Similarly, follow of D appears only here in the right hand side, so whatever is in follow of D will be whatever is in follow of A, that is A only. So this is how first and follow set for this grammar will look. They were asking us about the follow set for B, that is DA. Now the follow set for B is DA. D's index is 1, A's index is 3. They were asking us to write these indices in the descending order, so the answer will be A's index first and then D's index, that is 31. Now we need not have to calculate all the first and follow set for all the variables here, but just for showing you I did that here. In the exam time you only need to calculate the follow set of B. That will let G be an arbitrary group. Consider the following relations on G. R1 for all A comma B belonging to G, A R1B if and only if there exists G belonging to the group G such that A equals G inverse into B into G. R2 for all A comma B belonging to the group G, A related to B if and only if A equal to B inverse. Which of the above is or are equivalence relations? 4 options are given here. So this is a question coming from engineering mathematics topic regarding set theory. So here they are saying that we have been given an arbitrary group G, and they are asking among these relations R1 and R2 which of these are equivalence relations. Now an equivalence relation is one which is reflexive, symmetric as well as transitive. So we will go through both of these relations and see whether these are reflexive, symmetric as well as transitive. So for R1 we are checking for reflexivity. For any A we can say that E inverse into A into E equal to A, where E is the identity element. Since G is a group, G will have identity element belonging to G, and E inverse is nothing but E only, and E into A is A only, and that A into E will be again A only. So E inverse into A into E equal to A is true, which implies there exists G such that A equal to G inverse into A into G when G equal to E. Now in R1 they were saying that A is related to B if and only if there exists G belonging to the group. Now G can be anything, so clearly I have shown here that if we are taking G as E, then this condition satisfies, which implies A is related to B through relation R1. A is related to A through relation R1, meaning A is reflexive. Now coming to the second part, symmetric. Let A is related to B through relation R1, which will imply A equal to G inverse into B into G, that is given from the definition of the relation R1. Now multiplying G on this side, G into A will be equal to G into G inverse into B into G. G into G inverse will be identity element, that into BG will be BG only. Similarly, multiplying with G inverse on the right hand side of this part, G into A into G inverse will be equal to B into G inverse. G into G inverse is again E, identity element, that into B will be B only. So G into A into G inverse equal to B, which we can rewrite as B equal to G inverse into A into G, where capital G equal to small g inverse. Since the small g belongs to the group, G inverse also belongs to the group, so we can take some another G which is equal to this G's inverse. This way I have shown that B also equal to G inverse into A into G, which means B is related to A. So if A is related to B, B is also related to A. That's what I have shown here. So this relation is symmetric as well. Now we'll check for transitivity. Let us say A is related to B and B is related to C, which will imply A equal to G inverse into B into G and B equal to H inverse into C into H. Here H also will be some G only. In order to avoid confusion between this G and this G, they need not be equal. That's why I have written it as H. So this I will rewrite it as, on B's left hand side and right hand side I am multiplying it with G inverse and G. So G inverse into B into G will be equal to G inverse into H inverse into C into H into G. Now inverse of G inverse into H inverse will be equal to HG. That is, inverse of this part will be equal to this part. The proof of that is, see, G inverse into H inverse into H into G, multiplying these two, I can put the brackets in this way such that G inverse into H inverse into H into G. H inverse into H will be E only. So G inverse into E into G is G inverse into G only. That is again inverse into G, that is E only. So we have shown that this into this will be E, meaning one of these is the inverse of the other. So what we got is this part is the inverse of this part. So this I can rewrite as some other arbitrary G inverse into C into G. Now G inverse into B into G was nothing but A. So I have shown that A equal to some G inverse into C into G, which implies A is related to C as well. So we have shown if A is related to B and B is related to C, A will be related to C. So this relation is reflexive, symmetric and transitive, meaning R1 is an equivalence relation. Now look at R2. For all A, B belong to G, A related to B if and only if A equal to B inverse. Now this need not be reflexive itself, because if it has to be reflexive it should be A equal to A inverse. But in an arbitrary group, A and A inverse need not be the same element. They haven't given us a group, so which means we can take any random arbitrary group, and in that group A need not be equal to A inverse, meaning we can't say that R2 is equivalence relation. So only R1 is the equivalence relation, that is option D. In 16-bit 2's complement representation, the decimal number minus 28 is, 4 options are given here. So this is a question coming from number systems. They are asking us to find out 2's complement representation of minus 28 when we are representing it using 16 bits. Now to find out 2's complement, what we need to do is we'll take the 2's complement representation of plus 28 and then we take the 2's complement of that in order to get the 2's complement form of minus 28. So for plus 28, its binary form is 11100 using the minimum number of bits. Now in 2's complement form, you know all positive numbers should have 0 at the beginning and all negative numbers should have 1 at the beginning. So here we have 1 at the beginning, but 28 is a positive number. So in order to represent it in 2's complement, I will add one more bit, that is one more 0 at the beginning, and I will represent it as 01100. It's the same number. I just added one bit at the start so that the initial bit will be 0. Now 2's complement of this number will be, we take complement of each of the digits, that is 100011, and then we add 1 to it, that is plus 1, that's equal to 100100. Now this is 2's complement representation of minus 28. We started from 28 and then we reset 2's complement representation of minus 28. Now in the question we need to represent it in 16 bits, but here it is, we are representing it using 6 bits only. So in order to apply scaling, what we do is, if it's a negative number, we will be adding all ones to the left side. If it is a positive number, we will be adding all zeros to the left side in order to apply scaling when we are changing from lower number of bits to higher number of bits. So adding all ones, we will get 1111, 1111, 11, and then the rest of this number 100100. Now looking at the options, that is option A. Instead of doing it like this, you could have represented 28 using 16 bits, and then after that you could have done the 2's complement operation, but then you would have to write more number of bits, and here I just did the calculations using 6 bits and got the answer. At the end I was just adding ones. So option here is A. Two numbers are chosen independently and uniformly at random from the set 1, 2, 3, 4, etc. up to 13. the probability that their 4-bit unsigned binary representations have the same most significant bit is dash. So this is a numerical type question. In the question, they have given us this particular set containing 13 numbers, that is numbers 1, 2, 3, 4, 5, etc. up to 13, and they are saying that we are choosing 2 numbers from this set at random, chosen independently and uniformly at random, meaning the probability of choosing any number will be equal to choosing any other number from the set. Each of the numbers have equal probability of getting chosen. Now they are asking us what is the probability that their 4-bit unsigned binary representation will have the same most significant bit. So we need to choose 2 numbers, and they are asking what will the probability that the 2 numbers chosen will have the same most significant bit. Now this set is pretty small, there is only 13 numbers, so we can just write down their binary representation like this. I have written down the binary representation of the numbers 1 to 13. So if you take a look, the numbers 1 to 7 has the same most significant bit as 0 here, and the numbers 8 to 13 has the same most significant bit, that is 1. So we need to choose 2 numbers such that either their most significant bit will be 0 for both the numbers, or it should be 1 for both the numbers chosen. Now that probability I have written here, probability that we have the same most significant bit will be equal to probability that the most significant bit equal to 0 plus probability that the most significant bit equals to 1. Now probability that the most significant bit equal to 0 is probability that the m must be equal to 0 in the first try, that is when we are choosing first number, into probability that m must be equal to 0 in the second try, that is most significant bit of the second number is 0. This together will give the total probability that the most significant bit equals to 0. Similarly, for m must be equal to 1, we have the probability as probability that the most significant bit equal to 1 in the first try into probability that the m must be equal to 1 in the second try. Now we will try adding this. Probability that they must be equal to 0 in the first try is 7 by 13, because we had 7 numbers which had they must be as 0, and there are total 13 numbers. So this will be 7 by 13 into 7 by 13. The probability remains same in the first or second try. Plus 6 by 13 into 6 by 13. That is the probability that they must be equal to 1, because there are 6 numbers having m must be as 1, and total there were 13 numbers. So this total would be 49 plus 36 by 169, that's equal to 0.502. That's the probability. Which one of the following kinds of derivation is used by LR parsers? A. Leftmost. B. Leftmost in reverse. C. Rightmost. D. Rightmost in reverse. So this is a very straightforward question coming from compiler design regarding parsers. So there are 2 major kinds of parsers, that is LL parsers and LR parsers. Now in LL, these L stands for, the first L stands for left to right scan, meaning the input we are scanning from the left side to the right side, and the second L stands for leftmost derivation. Similar in LR parsers, the first L stands for left to right scan and R stands for rightmost derivation. Now from the question you can see that option, we can see it is rightmost derivation, so it is option C or D. Now LR parsers uses rightmost derivation in reverse form, because in a tree when we are constructing, the LR parser starts deriving from the bottom of the tree to the top finally. So we are saying rightmost in reverse. So the answer is option D. Now this was a very straightforward question. Please refer to the video lectures for the parsers to understand how we got all this. Consider a sequence of 14 elements, A equal to the sequence -5, -10, 6, 3, -1, -2, 13, 4, -9, -1, 4, 12, -3, 0. The subsequent sum ij equal to sigma k equal to I to j, A of k. Determine the maximum of sum ij where 0 less than or equal to I less than or equal to j less than or equal to 14. So given this sequence of numbers, we need to find out the subsequence that will give the maximum sum, and we need to find out what the maximum sum is. That's what they are asking us in the question. Now if you take a look, first of all we are asking subsequence here. That means the sequence should be contiguous. First of all, we can't just take the positive numbers and print the output. No, the sequence has to be contiguous starting from I to j. That is given clearly here in this sigma function. Now if you look at the numbers here, you will see that the first number is -5, meaning if we take the sequence from the start to the end, if we remove this number, that is minus 5, our sequence sum will increase by 5. So we definitely won't need to take minus 5 in any of the subsequences. We won't be taking this because this will only be adding a negative, and there is no other positive to the left side which will give us some outcome, some positive outcome by taking this minus 5. So I can safely remove this minus 5. Similarly, the next number is minus 10, that also I can safely remove. Now coming to the rightmost side, this is 0. Either we take this or not take this, it won't bring any change to the subsequent sum. But if you take a look here, the second one is negative 3. So if we are taking this 0 to some subsequent sum, we have to take this minus 3 as well. But this total sum is minus 3, which means if I am not taking these two numbers in our subsequence, then I can improve our sum by 3 at least. So I don't have to take these two numbers as well. So minus 3 and minus 0 I won't take. Now let us start from the whatever is left and then see what maximum sum we can take. Let us say I am taking 6, that is positive, fine. 6 and 3 I take, that is total sum will be 9. Now if I take these two numbers also, then from 9 it will be reducing by minus 3. So it will reduce from 9 to 9 minus 3, that is 6. Now let us say let us find out if taking these two numbers make any sense. Look at the third number. The third number will be 13. So if I take all of these 5 numbers, the total sum would be 6 plus 13, that is 19. So which means that if I was not taking these two numbers, I should have stopped the sequence at 6 and 3 only, that will give 9 only. But if I take these two negative numbers and this number as well, the sum will increase to 19 from 9. Now that is a very good thing for us. So we'll take these two as well. Now I am starting from here. I have reached till here. Now this is a positive number. Sure, I will take this. So the total sum here is 23, taking this much part. Now if I take a look at this, next is minus 9 and after that there is minus 10. So if I take these two numbers, our sum will reduce by minus 10. So let us see if there are any positive numbers to the right side of it. This much part will give minus 10. This much part will give plus 16. So if I am not taking this part, I have to stop the subsequence at here. But if I take this part also, I can include this part as well, which will give a total sum of 16 minus 10, that is plus 6. Now that is good for us. Plus 6 is fine. So we will include this part as well, which will give plus 6 sum. So the total was how much? 6 plus 3 is 9. 9 plus 13 is 22 plus 4 is 26 plus 4 is 30 plus 12 is 42 minus 10 is 32 minus 3 is 29. So the final answer is 29. Consider 3 concurrent processes P1, P2 and P3 as shown below, which access a shared variable d that has been initialized to 100. P1 does d equal to d plus 20, P2 does d equal to d minus 50, P3 does d equal to d plus 10. The processes are executed on a uniprocessor system running a time-shared operating system. If the minimum and maximum possible values of d after the 3 processes have completed execution are x and y respectively, then the value of x minus y is dash. So this is a question from operating system regarding process synchronization. Now here we have a shared variable d, but we are not applying any process synchronization, which means these statements can be executed in any order. So they are asking if that is the case and these processes are concurrent, they are running concurrently. If that is the case, what will be the maximum and minimum value of d after all these 3 got executed? And then they are asking what will be the difference between the maximum and minimum value of d. That's what we need to print as the answer. Now if you take a look here, P1 and P3 both are increasing d by 20 and 10 each. Now P2 is decreasing the value of d by 50. Now first let us try to find out the minimum. Now the minimum clearly happens when P2 makes changes to the d. Now let us say let us find out if there is any way if P2 can make a change to d and override the changes of P1 and P3. So let us see if that happens, if there is any case. So let us say P2 initially reads d. Now P2 will be having d's value as 100 now. Now after that P1 reads d. Let us say after P2 reads d, before it could write the value of d, let us say P1 reads and writes d. Now P1 will also read the value of d as 100 and then it will increase the value of 100 to 120. After that P3 will read 120 and then increase the value to 130. But if you see, the P2 still has the initially read value of D as 100 only, and let us say after that P2 writes the value of D. Now P2 will take D's value as 100 only, that is what it had when it read initially, and then it will write the new value, that is 100 minus 50, that will be 50 only. So D value will be 100 minus 50, that's equal to 50. Now this is the minimum value. This is the minimum because we are only applying the reduction operation here. The other two, P1 and P3, were increasing, and we have cancelled out that with D's execution, with P2's execution. Now minimum value will be 50. Now let's look at the max. Now let us look at the maximum possible value. The maximum value we can get if, let us say, P1 writes the values to D, P1 makes changes to D, that is increasing D by 20, and P3 also increases D by 10. And somehow if we can cancel out all the changes made by P2, we override the changes made by P2. If that is the case, then only 2 increments will happen on D and the final value will be 130. Now let us see if that is possible. Suppose P1 reads D. Now P1 thinks D's value is 100. After that P2 reads and writes D. So P2 will read D as 100 and then reduce D values by 50, and D will be 50 finally. After that, let us say P1 writes D. Now P1 thinks that D's value is 100 only. P1 will increase that D's value by 20, that is it will make it 120 and write the value of D. Now D's value has become 120. We have overwritten all the P2's changes. Now P1 wrote D as 120. After that, let us say P3 reads and writes D. So P3 will read 120 and then it will write 120 plus 10, that is 130. So the final D value will be 100 plus 30 equal to 130. So this is the maximum possible value because both the increment operations we are taking into account and we are cancelling out that decrement operation. This is the minimum value because only the decrement operation we are considering and both the increment operations we are cancelling out. So the value of maximum minus minimum will be 130 minus 50, that's equal to 80. 80 is the answer. An array of 25 distinct elements is to be sorted using quicksort. Assume that the pivot element is chosen uniformly at random. The probability that the pivot element gets placed in the worst possible location in the first round of partitioning is dash. So this is a very simple question coming from algorithm section regarding quicksort. Now in quicksort, what we do is, if we have an array like this, we'll be choosing one element as the pivot element and then we'll be placing that element in the right sorted position in the array, and all the elements lesser than that will be placed in the left hand side of this element, and all the elements greater than this would be placed in the right hand side of this element. And then we'll be calling quicksort in this part and this part to sort this part and this part as well. So that is how quicksort proceeds. Now in this, quicksort will give us the worst possible time case if the pivot element we choose goes to the leftmost side or the rightmost side. So either the pivot element chosen can be in the leftmost side. In that case, we will be placing that here and then we will be calling quicksort in the rest of this part, or we place the pivot element at the rightmost side and then we will be calling quicksort in the rest of the array. So in those two cases, it will be giving O(n) square complexity. Please learn about quicksort if you don't understand that part, to learn how we got the complexity as O(n) square in such cases. So pivot element will be placed in the leftmost side if we are choosing the smallest element. Similarly, pivot element will be chosen on the rightmost side if we are choosing the largest element. Now in the question they have given 25 distinct elements. So the smallest element there will only be one, and the largest element also there will only be one single element. So either the smallest or the largest element, there will be 2 elements out of 25. So if you are choosing these 2 elements out of 25, that will give us the worst case time complexity. So the probability of that is 2 out of 25, that is nothing but 0.08. 0.08 is the answer here. Let X be a square matrix. Consider the following statements on X. Statement 1, X is invertible. Statement 2, determinant of X is non-zero. Which of the following is true? 4 statements are given regarding which of these implies the other. Now this is a very straightforward question coming from linear algebra. When you learn linear algebra, you will see that if X is invertible, the determinant of X will be non-zero, and if the determinant of X is non-zero, X will always be invertible. These two are equivalent statements. I will give the proof of it as well. Let us take statement 1, X is invertible, which will imply that X inverse exists, and X inverse can be given by adjoint of X by determinant of X. That is the formula for X inverse. Now if this exists, which will mean that this determinant part will be non-zero. If this was non-zero, it will be something divided by a zero number which will be not defined. But since this is defined, we can say this part, the denominator is non-zero, which means determinant of x is non-zero. That is nothing but statement 2. Now if you look at statement 2, it says that determinant of x equal to non-zero, which means we can form the matrix adjoint of x by determinant of x. Adjoint of x matrix exists for every matrix. We can be sure that this matrix exists divided by this determinant value which is non-zero, which will give us inverse of the matrix, x inverse. This is a formula for inverse of the matrix. Now we see that x inverse exists, or we can write x is invertible, which is nothing but statement 1. So we see that from each of these statements we can conclude the other statement, which means both of these are equivalent statement. That is option C. For sigma equal to a comma b, let us consider the regular language L equal to set of all strings x such that x equal to a power 2 plus 3k or x equal to b power 10 plus 12k such that k is greater than or equal to 0. Which one of the following can be a pumping length for that is the constant guaranteed by the pumping lemma for the language L? And 4 options are given here. So this is a question coming from theory of computation section regarding pumping lemma for regular languages. Now pumping lemma for regular language I have rewritten here. For any regular language L, there exists an integer p which is the pumping length such that for all strings w belonging to L with length of w greater than or equal to p, w can be divided as 3 strings x, y, z, that is 3 substrings, such that it satisfies these 3 conditions. One is that length of y should be greater than 1, 2, length of xy should be less than or equal to p, and 3, for all n greater than or equal to 0, x, y power n, z belongs to L. So pumping lemma says that for any strings belonging in a regular language which has at least length as the pumping length, we can divide it as 3 substrings x, y, z, such that if we take this string, length of y should be greater than 1, length of greater than or equal to 1, length of x, y together should be less than or equal to the pumping length, and also if this y part, if we take 0 or 1 times, still that string should belong to the language L. That is, if w is x, y, z, strings x, z, x, y, z, x, y power z, y power 2 z, x, y cube z, etc. All these strings should still belong to the language L. So that is pumping length. Now let us take a look at our language here and see what should be the pumping length here. So our language is a set of all strings x such that x is either of the form a power 2 plus 3k or of the form b power 10 plus 12k, which we got from the question only. So x should be strings of either this form or this form. What this form generates is that the strings of a's such that it will have length. Let us say if k is 0, k should be greater or equal to 0. If k is 0, it will generate a power 2, that is nothing but string of a's of length 2, that is aa. If k is 1, it will be a power 2 plus 3, that is a power 5, that is 5 a's. If k is 2, that is a power 2 plus 3 into 2, that is a power 8, that is 8 a's in this format, etc. So basically this language generates strings of all a's having length 2, 5, 8, 11, etc. It keeps on growing like that. So that means it is each string in this language will be having lengths which increases in multiples of 3. First string had a length of 2 and then increase it by 3, that is the second string, that is length of 5, which we increase it by 3, again we will get 8, etc. So each string has lengths which increases in multiples of 3, which means that the length of y part, if we are taking the string and dividing it into x, y, z, 3 parts, then the length of y part must be a multiple of 3. I'll show you why. Let us say I'm taking a sample string w equal to a, something like this, let us say, and let us say I'm dividing it in this format x, y, z. So x is a here, y is a here, z is a here. Now if this is how I'm dividing these strings, which will mean that x, z itself should belong to the language, that is taking this y 0 times, that is a, and taking y 2 times, that will be a. These strings should belong in the language if we are taking y like this. But clearly this is 3 times a, that doesn't belong in this language. It should be, length of string should be 2, 5, 8, etc., which is increasing in multiples of 3. So but this is what, this was a length of 3, this had a length of 5, this string has a length of 7, etc. So it increases in multiples of 2. That is nothing but the length of y which we took here. So if we had to make these strings increase in multiples of 3, which will mean that we have to take y part as 3 only. 3 or multiples of 3 we can take. That is, if w was a, and if I am taking x as a, y as a, and z as a. Now this string has a length of 5. If we take y 0 times, this string will be a, which will have a length of 2. If we take y 2 times, it will be 8 times a, that will be length 8. So basically this is strings of length 2, 5, 8, etc. So it increases in multiples of 3. That is nothing but the length of y, that was a multiple of 3. So if we have to make strings in this language, so if you see here, if we took y which had a length of 3 and the initial string w belonged to L, which means all the strings generated will also be belonging to L. So clearly the length of y must be a multiple of 3, and also it should be greater than or equal to 3. The length of y had to be greater than 1, and it should be a multiple of 3, meaning it should be greater than or equal to 3 in multiples of 3. Now coming to the pumping lemma part, we have divided w such that it is x, y, z, and length of y is greater than or equal to 3, which we got from there. And which, see, so if length of y itself is greater than or equal to 3, the total length of xy will also be greater than or equal to 3, and xy is the pumping length here. Xy should be less than or equal to pumping length, which means for our string the pumping length p should also be greater than or equal to 3. That is because the y part itself was greater than or equal to 3, and xy together will be at least more than this. So pumping length had to be greater than or equal to 3, which means in order to take a string from this language such that we can pump it to produce other strings in the language, that string should have a length of at least 3. Now if you look at the strings in the language, there is no string of length 3. The only string having length greater than 3 is a string of length 5. So this will be the first string which we can choose, and we can pump it such that we can produce strings in the language. But the length of this string is 5, but we are not worried about that. The pumping length p should be strings of length greater than or equal to 3. Only that the first string belonging to the language greater than or equal to 3 had a length of 5. But we are not worried about that. P should be greater than or equal to 3 for this part. Now coming to this part of the language, it is set of strings of all b's having length 10, 22, 34, etc. Again, this we got by making k equal to 0. If k equal to 0, it will be b power 10, that is all b's of length 10. If k is 1, it will be b power 10 plus 12, that is b power 22, that is string of length 22. If k is 2, it will be string of length 34, etc. Similarly, if you take a look here, all of these strings have lengths increasing in multiples of 12. 10 plus 12 is 22, 22 plus 12 is 34, which means that length of the y part if we take a string from this language and we are making it x, y, z, then the length of the y part must be a multiple of 12, and also it should be greater than or equal to 12 because it was greater than or equal to 1. Length of y should be greater than or equal to 1. So which means y part should be greater than or equal to 12, which means the xy part together should be greater than or equal to 12. So the pumping length has to be greater than or equal to 12. We have to take strings of length greater than or equal to 12 in order to be able to pump strings in this language. Now if we take these two, here it says it should be greater than or equal to 3, it says it should be greater than or equal to 12. So in total the pumping length for this whole language should be greater than or equal to 12. Now if you look at the options, 3 is false, 9 is false, C 5 is false. So the only option which satisfies greater than or equal to 12 is option D, that is 24. So D is the right answer. Let G be an undirected complete graph on n vertices where n is greater than 2. Then the number of Hamiltonian cycles in G is equal to, 4 options are given here. So this is a question coming from graph theory. Here they are asking us about Hamiltonian cycles. So a Hamiltonian cycle is a cycle such that we start from one node in a graph and we visit every nodes in the graph and then we come back to the same node. So such a cycle which visits every node in the graph is known as Hamiltonian cycle. So here they are saying that G is an undirected complete graph on n vertices. Now if that is the case, they are asking which of the following options will give all the Hamiltonian cycles in the graph. Now we'll take each graph starting from n equal to 3. It was given n is greater than or equal to 2, n is greater than 2, sorry, which means n should be 3, 4, etc. So we'll draw these graphs and find out Hamiltonian cycles in that, and then we'll look at the options and find out which is the right answer. So for n equal to 3, if you take, this is the graph which is the undirected complete graph. There is only one graph like this. So in this, if you see, there is only one cycle, that is this cycle, such that A, B, C and then back to A. If you start from B or if you start from C, we will be getting the same cycle, that is A, B, C, A. But if these nodes are labeled, then A, B, C, A is this cycle, A, C, B, A is this cycle in the reverse form. Now in the question they haven't given whether the nodes are labeled or not, so we are not sure if this should be considered as one single cycle or if we should consider the reverse as a different cycle and it should be two cycles. So for this one we'll take 1 or 2. 1 if we have to consider one cycle only for every cycle, and 2 if we have to consider the reverse as a different cycle. Now coming to n equal to 4, this is the complete graph here. There are 3 unique cycles in that which can be drawn by graphs like this. So this is one cycle coming like this. This is another cycle. From here I start here, I go here, I come here, I come here. Or third cycle, I start here, I go here, I come here, I come here, and then I go here. These are the only 3 cycles possible in this graph. You can draw various possibilities in this graph to get cycles, and you can verify that these 3 are the only ones possible. Now here also again, if the reverse I am considering as a different cycle, if it is labeled, then I should consider the reverse as a different cycle. In that case I will get 2 times as this. So either this will be having 3 cycles, or if I am considering the reverse as a separate cycle, it will be 6 cycles actually. So it will be 3 or 6 for n equal to 4. On n equal to 3 it will be 1 or 2. Now let us look at the options. For n equal to 3, 3 factorial is 6, that is neither 1 or 2, that is wrong. B is 1, which may be the answer. C is n minus 1 factorial by 2, that is 2 factorial, that is 2. D is n minus 1 factorial by 2, that is 3 minus 1, 2 factorial by 2, that is 1. So this gives 2, this gives 1, this gives 1. All 3 satisfies 1 or 2. Now coming to n equal to 4, we have the answer as 3 or 6. So clearly B is 1, that is wrong. Now C is n minus 1 factorial, that is 3 factorial, that gives 6. And D is n minus 1 factorial by 2, that gives 3. So clearly it is n minus 1 factorial if we are considering the reverse of a cycle as a different cycle. In that case it is n minus 1 factorial. But if we are considering the reverse of a cycle also as the same cycle only, then we will be getting n minus 1 factorial by 2. Now in this year for GATE, the actual answer they gave was n minus 1 factorial by 2, the reverse being not considered as the same cycle. But then people challenged this question, and option C, n minus 1 factorial, was also accepted by GATE authorities as the right answer. So for here these two was accepted in this year. But if this question is asked in general, we should be going with this one. They haven't given it is a labeled graph, so we should not assume that the reverse is also the different cycle. We should be taking the reverse of a cycle as a same cycle only. So in general go with this answer, but this year in GATE both these answers were accepted.
This is a digital logic question based upon number system. We have been given the numbers x, y and z all in the sign magnitude form such that z equal to x minus y. Now these x and y are both represented using n bits. So we need to find out what is the minimum number of bit that z might require. Now first of all, let us understand the range of this sign magnitude form. As we know, for n bits, the range of these sign magnitude numbers would be from minus of 2 to the power n minus 1, minus 1 to 2 to the power n minus 1, minus 1. So let us understand this with an example. Let us take the value of n to be 5. Then in that case, the range would become minus of 2 to the power 5 minus 1, minus 1 to 2 to the power 5 minus 1 minus 1, which is minus 15 to plus 15. So this is the range that we have got with 5 bits in sign magnitude form. So now let us look at the result which we have. We want the computation z equal to x minus y. Now let us check for the worst case. Let us substitute x to be the maximum possible value which is possible with 5 bits in sign magnitude form, and that we just found out to be 15, the maximum number. Now let's substitute y with the minimum number, which is possible using 5 bits in sign magnitude form. That would be minus 15. So now the result we are getting is z equal to x minus y equal to 15 minus of minus 15, and that is plus 30. Now as we can see that this number plus 30 cannot be represented using 5 bits in sign magnitude form. For that we would need 6 bits. Hence we just proved the statement that if x and y are both n bit numbers, then their subtraction might result into an n plus 1 bit number. Hence the minimum number of bits that z would require in order to represent this computation correctly would be n plus 1 bits if x and y are both n bit numbers. Hence we would go with option C, that is n plus 1 bits.
The value of 3 power 51 mod 5 is dash. So this is again a very simple question. Here what I will do is I will be taking simple 3 power 0 mod 5, 3 power 1 mod 5, etc. and then I will find out when that pattern repeats, and after that we can just take the value of 3 power 51 based on that pattern. So 3 power 0 mod 5 is 1, 3 power 1 mod 5 is 3, 3 power 2 mod 5 will be 4, 3 power 3 mod 5 will be 2. All these you can get easily from a calculator, and 3 power 4 mod 5 will be equal to 1. So if you see, once I reach 4, the pattern starts repeating. After that 3 power 5 mod 1 will be again 3 only, because we already got 1 here, which is same as 3 power 0 mod 5. After that if I again multiply with 3, I will be getting this number again only, that is this 3 here. So this pattern keeps on repeating. So this pattern repeats in multiples of 4. So for any number, if that, for example, if I take any 2 and if I increase the value of 2 by multiples of 4, the next number will be 6. After that if I add 4, the number will be 10, etc. Then 3 power n mod 5 such that n is 2, 6, 10, 14, etc. all these will be having the same value, because these increase by values of 4, and after 4 this cycle repeats. So in order to find out 3 power 51 mod 5, what I will do is, for 51 I will take 51 mod 4, that will be 3. So the value of 3 power 3 mod 5, 3 power 3 plus 4 is 3 power 7 mod 5, 3 power 7 plus 4 is 3 power 11 mod 5, etc. If I keep on adding by 4, I will get 3 power 51 as well, because it increases by 4. Now all of these 51, all of these will be having the same value of 3 power n mod 5, because it repeats after cycles of 4. So 3 power 3 mod 5 was 2. So we can say 3 power 51 mod 5 will also be 2 only. So the answer is 2. That's because 3 power 51 mod 4 and 3 mod 4 is the same. Answer is 2. Which of the following is not a valid identity? 4 options are given here. So we need to find out among these options which of these given in LHS and RHS are not equals. So this is a question coming from digital logic design regarding XOR operator. Now if you look at option A, if x equal to 1 and y equal to 1 and z equal to 0, let us assume, then LHS will be equal to 1 plus 1 XOR 0. That will be equal to 1 XOR 0, which is 1. Now RHS will be x XOR y plus z, that is 1 XOR 1 plus 0, that will be equal to 1 XOR 1, that is 0. So clearly LHS and RHS are not equal here. So the answer is option A, which is not equal. Here LHS is not equal to RHS. For B, C and D, you can try out LHS and RHS, and you can draw the truth table and verify that all those are same. So answer here is option A. This is a C programming question given here. We have been given this particular code snippet, and they are asking the value printed by the program is dash. So we need to find out what the value would be that is printed by this program. Now let us take a look at the program. Here we are assigning two variables x and y as x equal to 2 and y equal to 5 here, as I have given here. After that we are calling the function jumble with y comma x, meaning we are calling jumble with 5 comma 2. Now what happens in jumble, if you are passing x and y to the function jumble here, it will be returning 2 into x plus y. X gets assigned as 2 into x plus y, and we are returning that value here. Meaning if you are calling jumble of 5 comma 2, we are returning 5 into 2 plus 2, that is 10 plus 2 equal to 12. Now all of these calls are called by value, meaning whatever x and y we have here in the main function, that won't get affected inside this function, but whatever we are returning from this function, that is getting assigned to x and y. So in that way only x and y is changing here. So jumble of 5 comma 2 will be returning 12, and that is getting assigned to y, meaning y now becomes 12 and x will remain at 2. After that we are calling again jumble of y comma x, meaning we are calling jumble of 12 comma 2. Now what that will do is, it will be returning 12 into 2 plus 2, that is 24 plus 2, that is 26, and that we are assigning to x here, meaning x will become 26 and y will remain at whatever value it had earlier, that is 12 only. Now look at the print statement, print of percentage d x, meaning we are printing x value here, that is clearly 26. 26 is the answer. This is a C programming question they have given here. So here we have been given this particular code snippet, and they are asking the number of child processes created is dash. So let's take a look at the program. What it is doing is, we have an integer I. For I equal to 0, I less than 10, I plus plus. If I percentage 2 equal to 0, call fork and return 0. Now what fork does in a Unix system is that it will split the current process into two processes. That is, basically it will create one child process as well, and both the process will be executing parallelly from that point onwards. So I have drawn one particular diagram here. Here each vertical line represents one process and each horizontal line represents one splitting process. So I will explain that here. So initially we have only one process given by this main line. So initially I is 0 as given in this for loop. So if I percentage 2 equal to 0, they are checking if I is even. Now 0 is even, it will do fork, meaning at this point where I equal to 0, it will be performing fork once. Okay. Now when it performs fork once, it will mean it will create one additional child process that is given by this particular vertical line. So after executing I equal to 0, there will be two processes given by these two, and in this process also now I will be equal to 0 only, but I equal to 0, but this fork statement is already executed, so both the process will continue only from this part, that is it will make I equal to 1 and then continue the loop. So this process won't split any more further childs immediately. At 0 the main function will create one child process and then that's it, then we will continue execution. At I equal to 1, I is not even, so neither of these processes will be splitting any more children. I equal to 2, I percentage 2 equal to 0, that condition satisfies. So this process, the main process we had, will call fork again, meaning it will create one additional child process. But we also had one child created at I equal to 0. Here also I becomes 2 now, so this will call fork again. So one additional child process will be created for this created child process, meaning now there will be 1, 2, 3, 4 processes in total. After I equal to 0, we had 2 processes in total. After I equal to 2, we will be having 4 processes in total. Now I becomes 5, that is odd, so none of these 4 processes will split again. At I equal to 4, now it is even, meaning the main process will be splitting. This process will also be splitting one more child. This process will also be creating one more child. This will also create one more child. So we had 4 processes, each will create one additional child, meaning there will be 4 into 2 or 8 processes in total, meaning after 4, when I becomes 4, there will be 8 processes in total. Similarly, when the next even value is I equal to 6, at this point we already had 8 processes, each will be creating one more child, meaning there will be a total of 2 times of this, that is at 6 there will be 16 processes in total. Similarly at 8, again the 16 process will create one child each, meaning there will be 32 processes in total. So in the question, so after 8 I becomes 9, there will be no more splitting, and I doesn't become 10 because the condition is I less than 10. So at this point it stops, there won't be any more children split. So in total there are 32 processes currently, and in the question they were asking the number of child processes created is dash. We had one process initially, so that can't be considered as a child process. Total process were 32, meaning the number of child process created is 32 minus 1, that is 31. This question's answer is 31. Let u equal to set 1, 2, 3 etc. up to n. Let A equal to set of all elements lowercase x comma uppercase x such that lowercase x belongs to uppercase x where uppercase x is a subset of U. Consider the following two statements on the number of elements in A. Statement 1, number of elements in A equal to n into 2 power n minus 1. Statement 2, number of elements in A equal to sigma k equal to 1 to n k into nck. Which of the above statements is or are true? 4 options are given here. So in this question, this is a question from engineering mathematics. First of all, we need to find out how many elements will be there in A if this is U, and then we need to find out which of these statements are true about that. Now it's given that U equals to set of all elements 1, 2, 3 etc. up to n. Now any set of n elements will be having 2 power n subsets. Okay. Now there will be NC0 subsets of size 0, that is the number of ways of choosing 0 elements from U. NC1 subsets of size 1, that is the number of ways of choosing 1 element from this set. NC2 subsets of size 2, that is the number of ways of selecting 2 elements from U, meaning there will be NC2 subsets of size 2 etc. There will be NCn subsets of size n, which means that there will be NCk subsets of size k for k ranging from 0, 1, 2 etc. up to n. We are just writing the size of subsets and how many subsets there will be of that size. Also, if the size of the set X is Y, imagine, then there will be Y elements of the form X comma X which will belong to U. What I said here is that, so let us say X is this set 2, 3, 5. Now size of X is 3, which means there will be 3 elements which will belong to the set U based on this X. This is X, so there will be 2 comma X, 3 comma X and 5 comma X. These 3 are the elements which belong to U, which belong to A, sorry, it's A actually. Okay, so again I am reiterating it. If the size of X is Y, here in the example it was 3, then there will be Y elements of the form X comma X which will belong to the set A. See here again, if size of X was 3, meaning there are 3 elements which belongs to A based on this set X. Now these two statements, if we combine, we will see that the total number of elements which will be there in A will be equal to sigma k equal to 0 to n k into nck. See, that's because if there are nck subsets of size k, each of these sets will be contributing k elements to A, that we got from this statement. If the size of a set is k, there will be k elements which will be adding to A, which means if there are nck subsets of size k, nck into k elements will belong to set A because of that particular subset of size k. So if you are taking all subsets of size 0, 1, 2 etc. up to n, that will give all the subsets. So the total number of elements will be sigma k equal to 0 to n k into nck. K is the number of elements which go to A based on one set which has a size of nck. Now which has a size of k, that will be, and there will be nck subsets of that size. Now this is nothing but sigma k equal to 1 to n k into nck. Since when k is 0, this k will be 0, so 0 into something will be 0 only. So this we can rewrite as sigma k equal to 1 to n k into nck. That is nothing but statement 2. So statement 2 is correct here. Now we look at statement 1 here. It is saying number of elements in A will be equal to n into 2 power n minus 1. So we'll take sample n values, n equal to 2 and n equal to 3, and we'll try to see if the statement holds for that. So for n equal to 2, we know the number of elements will be equal to sigma k equal to 1 to n k into nck. That will be sigma k equal to 1 to 2 k into 2ck. That is nothing but 1 into 2c1 plus 2 into 2c2. That is 2 plus 2, it will be equal to 4. Now 4 we can rewrite as 2 into 2 power 2 minus 1. 2 power 2 minus 1 is 2 power 1, that is 2. 2 into 2 is 4. So this is nothing but n into 2 power n minus 1 when n is equal to 2. So for n equal to 2, this statement holds, statement 1. We'll try for n equal to 3 as well. Sigma k equal to 1 to n k into 3ck, that is the sum value. That will be equal to 1 into 3c1 plus 2 into 3c2 plus 3 into 3c3. That's equal to 3 plus 6 plus 3, that is 12, Now 12 again I can rewrite as 3 into 2 power 3 minus 1. 2 power 3 minus 1 is 2 square, that is 4. 4 into 3 is 12. So this will be equal to n into 2 power n minus 1 when n is equal to 3. Similarly, you can verify for larger n values as well, but you will see that statement 1 holds. So statement 1 is also correct. I am not showing the proof that this will be equal to this because we don't need to do that for gate. If you can take a few n values like this and you can verify it holds, then that is enough to answer for gate. So statement 1 and 2 is right. So the answer will be both 1 and 2. Consider the following relations P, Q and R. Three relations are given here. How many tuples will be returned by the following relational algebra query? And a relational algebra query is also given. So this is a question coming from relational algebra topic in DBMS. So here we need to run this query on these three relations and find out how many tuples will be there in total. So we look at this query. So the first part is pi of x, that's a projection with selection sigma p dot y equal to r dot y and r dot v equal to v2 on p cross r. So here we are doing cross product of this table with this table. There are 4 tuples here and there are 4 tuples here. So total number of tuples in p cross r will be 16. And on top of that we are adding conditions such that p dot y equal to r dot y and r dot v equal to v2. So if you look at this condition r dot v equal to v2, there is only 2 tuples in R which satisfy this condition, that is y3 v2 and y2 v2. So in the cross product we only need to consider these 2 tuples. These 2 tuples we don't need to consider. So among these 2 tuples there is one more condition, p dot y equal to r dot y. Now r dot y here is y3 and y2. If you look at y3, there is not a single tuple in p which has y3. It has only y1, y1, y2 and y4. So for y3 there is no tuple here. So in cross product there won't be nothing matching with y3 here. Now looking at y2, p dot y equal to r dot y, there is one tuple with y2 here. So in total there will only be one tuple because the first query was only returning these 2 tuples, and for this tuple there is nothing matching in p, and for this tuple there is only one tuple here matching in p. So in total the final number of tuples will be 1 only, that is given by this x2, y2, z2 matching with y2, v2. That's what I have given here, x2, y2, z2 matching with y2 and v2. So this is the output of this selection query here. On top of that we are applying projection x, meaning we are only selecting the column of x. So the output of this applying this projection query also will be this one, just this only this column x having value x2. So that is the output of this query. Now we look at the output of this query here. Here again we are doing q cross r. So q has 4 tuples, r has 4 tuples, so q cross r will have 16 tuples in total. On that we are applying selection such that q dot y equal to r dot y and q dot t greater than 2. So if you look at this condition, q dot t greater than 2, there are only 2 tuples, this one and this one, which satisfies q dot t greater than 2. So we only need to consider these 2 tuples in q here. On top of that we are applying one more condition, q dot y equal to r dot y. So if you take this tuple x1, y2, 5, here y is y2, and that y we need to match with r dot y. So for y2 there are 2 tuples here matching, which has the same value as y2. There are 2 tuples here with y2, that is this one and this one. So the cross product will give x1, y2, 5, that is this tuple. Cross product means matching with this y2 tuple and this y2 tuple, that is y2, v3. Again same x1, y2, 5 matching with y2, v2. That is these 2 tuples. Similarly for this tuple x1, y1, 6, there is only one tuple here which has the same y, y1. So that one also we will write x1, y1, 6 matching with y1, v1. So the cross product and the selection together will give 3 tuples here, and from there again we are doing projection of x. That means we are selecting only x values from here. So if you look, there is only one single x value, that is this one. So this query will be returning column x with only one value, that is x1. Now from this one we are subtracting this, that meaning we are subtracting x1 from x2. Now what that means is from this table we need to remove all the tuples which has this value, that is x1, but there is no tuple here which has value x1, so there is nothing to remove. So this minus this will give this only, that is x2. X is the column header and x2 is the tuple, so this table has only one tuple x2, so the answer is 1. What is the minimum number of 2 input NOR gates required to implement a 4 variable function expressed in sum of min times form as f equal to sigma 0, 2, 5, 7, 8, 10, 13, 15? Assume that the inputs and their complements are available. So this is a question coming from digital logic section regarding minimization of a function using K-map. So if you don't know how to minimize a function using K-maps, please refer to the video lectures for K-map from digital logic topic and first learn about it and then come back here. So here I have drawn the K-map for this particular function given in question. So it was saying that it's a sigma function and 0, 2, 5, 7, 8, 10, 13, 15 will be ones. So in the place of 0, 2, 5, 7, 8, 10, 13 and 15 I have put 1. The rest all will be zeros. And after drawing this we will try to find out prime implicants from this. So if you take these ones, these 4 1 I can group together like this, and these 4 ones I can group together like this. Now there is no more groupings which we can do in this figure. Now we will try to find out the expression here. So for this particular group you will see that A changes from 0 to 1, B stays constant from 1 to 1, so we will write B. Here A changes from 0 to 1, C changes from 0 to 1, D remains constant at 1, so this will be BD for this one. Similarly for this one it will be A changes from 0 to 1, B remains constant at 0, 0, so B, instead of B we will be writing B complement. Similarly here C changes from 0 to 1, D remains constant at 0, so we will be writing D complement. So this function is BD plus B complement D complement. Now, that is nothing but B XNOR D. Now implementing XOR or XNOR using NAND and NOR gates, the minimum number of NAND gate required to implement XOR function is 4 and XNOR is 5. The minimum number of NOR gates required to implement XOR is 5 and XNOR will be 4. So this I got directly from the video lectures for and XOR and XNOR realization using NAND or NOR gates. Please refer to that if you don't know this. So if we know this, we can, based on this we can directly answer this question. But in this question they have given one more point, that is assume that all the inputs and their complements are available. So these values we get when the inputs are available only in the true form, that is A, B, C and D. But they are saying that inputs and their complements are also available, meaning A, B, C and D are available, and on top of that A complement, B complement, C complement, D complement are also available. So now in that case we need to find out if there is any better way to realize this. So this is what? NAND realization using NOR gates. NAND realization using XNOR realization using NOR gates. XNOR realization using NOR gates, normally it will take 4, but in our case, since complements are also available, let us see if we can reduce it from 4 to further down. So the expression is BD plus B complement D complement. Now we know we have to implement it using NOR gates. So at the end it should be some function plus some function the whole complement, because the final gate will be a NOR gate. So input should be something plus something, the whole complement should give us BD plus B complement D complement. So in this form directly we can't get that particular form using NOR gates. So I will try to transform this function here. So if you see AB plus C, we can rewrite as A plus C into B plus C. So this is just distributive law, distributing plus over star. Now the same thing BD plus B complement D complement I will rewrite as B plus B complement into B plus D complement plus D plus B complement plus D plus D complement. Now B plus B complement will be again 1 plus 0 form, this will be 1 only. D plus D complement will be again 1 plus 0 form, which will be 1 only. So these two we can ignore. So the rest would be B plus D complement into B complement plus D. Now this I can write as A plus B, the whole complement form. AB will be A complement, AB will be equal to A complement plus B complement, the whole complement. Something plus anything else, the whole complement is NOR only. Okay, so this into this we can rewrite as this part the whole complement, that is B plus D complement, the whole complement, plus b complement plus d, that is this part, the whole complement, that is b complement plus d, the whole complement, and the complement of the entire thing. This is just De Morgan's law. AB we can rewrite as a complement plus b complement, the whole complement. So we got this one. So if you look, this is just this part plus this part, the whole complement, that is NOR gate. And each of this part also, it is something plus something else, the whole complement. Again, this also we can input to a NOR gate, this also we can input to a NOR gate. That is what I have given in this particular diagram here. B and D complement, we are giving it to a NOR gate. Similarly, B complement and D also we are giving to another NOR gate. So this will be B plus D complement, the whole complement. This will be B complement plus D, the whole complement. And these two coming to a NOR gate, that is nothing but this particular expression. That is B complement, sorry, B plus D complement, the whole complement, plus B complement plus D, the whole complement, the whole complement. That's what will be coming out of here. That is nothing but what we have here. That is BD complement plus BD complement plus B complement D, that is again BD plus B complement D complement. This was our initial function. So clearly we can implement this using 3 NOR gates. So the answer to this question is 3. Consider 3 machines M, N and P with IP addresses 100.10.5.2, 100.10.5.5 and 100.10.5.6 respectively. The subnet mask is set to 255.255.255.252 for all the 3 machines. Which of the following is true? 4 options are given. We need to find out which among M, N and P belong to the same subnet. So this is a question from computer networks topic regarding subnet masks. So how a router finds out a given IP address belongs to which network is that it will do the bitwise AND of the given IP address with the subnet mask, and whatever value it will get, it will compare it with the network ID of each of the networks that the router knows. And if the bitwise AND of an IP address and its subnet mask is same as the network ID of any particular network, then that IP address will be forwarded to that particular network. That's how a router finds out a given IP address belongs to which subnet based on its network ID. So what here we will do is, we will do the bitwise AND of M, N and P. So these are 3 IP addresses belonging to 3 different machines. So for each of the IP addresses, we will do the bitwise AND with the subnet mask. Subnet mask is same for all, that is given in the question. And then we'll find out the network ID. Bitwise AND of subnet mask and IP address will give the network ID of that particular IP address. And based on the network ID, we'll get which is the subnet. So if all 3 has the same network ID, that will mean all 3 will belong to the same subnet. And if all 3 has different network IDs, it will mean all 3 belong to 3 different subnets. So now we'll do that bitwise AND of subnet mask and IP addresses and find out the network IDs. So if you see, the first 24 bits of all the IP addresses are the same, that is 100.10.5, 100.10.5, 100.10.5, that is same for all the 3. So in that part the network ID won't differ, only in the last 8 bits, that is for first one it is 2, second one it is 5 and third one it is 6. Only in the last 8 bits we need to check to see whether these belong to different subnets. So for M, the last 8 bit is 2, that is 0000. 0010. Similarly for N it is 5, that is 00000100, and for P it is 6, that is 00000110 as given here. Now subnet mask is 252 for the last 8 bits. Now that is 111111100. We will do bitwise AND of the subnet mask with each of these and find out what we are getting. So if you see, in the last 2 bits of the subnet mask is 0, so this part will become 0 only for all 3 M, N and P. So only in the first 6 bits, which is 1 in the subnet mask, we need to worry about in M, N and P. So M will be giving 0, that is the first 6 bits. N in the first 6 bits is 1 and P in the first 6 bits is 1. So as you can see, N and P will have the same subnet. M will have a different subnet compared to N and P. So M's network ID will be 100.10.5.0 and N's network ID would be 100.10.5. What we got here 1. Similarly, P's network ID would be 100.10.5.1 as we got here. So as you can see, N and P belong to the same subnet. M is in a different subnet. So the answer is option D, N and P. Consider three 4-variable functions f1, f2 and f3 which are expressed in sum of min terms as f1 equal to sigma 0 2 5 8 14, f2 equal to sigma 2 3 6 8 14 15, f3 equal to sigma 2 7 11 14. For the following circuit with one AND gate and one XOR gate, the output function f can be expressed as this is f1 and f2 XOR f3 is f. So in the question they are asking what is the minimum sum of product form for f. Now this is a question from detailed logic section. So one way to do this is that we can find out the minimum sum of product form for f1, f2 and f3, and then we can find out f1 and f2 and we can do XOR with f3 and try to find out what the function f stands for, but we don't need to do all that in order to answer this question. So how to do this is, if you see, initially we have to do f1 and f2. Okay, and f1 is given as sigma of 0 2 5 8 14, f2 is given as sigma of 2 3 6 8 14 and 15. So when we are doing f1 and f2, the output will be 1 only if it is 1 in f1 as well as 1 in f2. So we just need to find out the numbers which are common in f1's sigma function and f2's sigma function. Just take the numbers which are common in both of those. Only those will be 1 in both f1 and f2, and when we are taking AND, only those will be 1 finally. So if you see, 0 is there in f1 but it is not there in f2, so we can remove this. 2 is there in both, 5 is there in f1 but not in f2, so this we can't take. 8 is there in both, 14 is also there in both. Similarly 3 is there only in f2, so we can't take this. 6 is there only in f2, we can't take this. 8 is there in both, 14 is there in both, 15 is there in f2 only. So f1 and f2 will give only these numbers, 2, 8 and 14. That is here, 2, 8 and 14. So f1 and f2 will be sigma of 2, 8 and 14. Now we are taking XOR with f3. XOR of f3 will be sigma of 2, 7, 11 and 14. Now XOR of 2 function will be 1 only if it is 1 in exactly one of those two functions. That is, if there is a number which is 1 in f1 and 0 in f3, or it is 1 in f3 and 0 in f2, only those numbers will be 1 in XOR of these two. So if you take a look here, 2 is there here and 2 is here also, meaning for 2 it will be 1 here and 1 here. So XOR of that will be 1 XOR 1 will be 0 only. So 2 we can't take. 8 is there here, 8 is not here, so 8 we can take. 14 is there in both, so we can't take 14. 7 is there in f3, 7 is not there in f1 and f2, so 7 I can take. Similarly 11 also I can take because it is there only in the function f3. So this XOR this will give 8, 7 and 11. That is given here, sigma of 7, 8 and 11. Looking at options, that is option B. That's the right answer. Consider the augmented grammar given below. S dash gives S, S gives left bracket L right bracket or ID, L gives L comma S or S. Let I0 be equal to closure of S dash gives dot S. The number of items in the set go to of I0 comma left bracket is dash. So this is a very straightforward question coming from compiler design topic regarding LR parsers. So in question they have given us that I0 is the closure of the set S dash gives dot S. And if they are asking on seeing the symbol this, that is given as go to of this, what will be the new set and how many items will be there in that set. So first of all we will try to find out the closure of the set S dash gives dot S, that is given as S dash gives dot of S. Now what the dot symbol means is that whatever I have seen before the dot symbol, all that I have seen already from the input, and whatever appears after the dot symbol, that is the remaining input to be seen. And also if the dot symbol appears before any variable, the productions for that variable also we will write down in the same set itself with the dot symbol at the start. So for S dash gives dot S, we see that S is a variable here and the dot is appearing just before a variable. So S production also we will write down, that is S gives dot at the start, left bracket L right bracket, that is this production, or dot ID, ID is this production. Now this is the closure of the set I0. There will be no more productions left because dot is appearing before terminals in both the cases now. When it is appearing before terminals, there is nothing more to expand. So now we will find out the go to set of I0 on seeing input left bracket. On seeing input left bracket, you will see this dot will move here. Now that is given as the set S gives left bracket dot L right bracket. On these two productions we can't take because we can't move on seeing the input left bracket for these two productions. Now if you look here, the dot is appearing before L now, meaning we can expand L as well. L gives dot L comma S, that is this production, or L gives dot of S, that is this production. Dot I have appended at the start. Again now dot is appearing before a new variable S, meaning S also we need to expand here, that is S gives dot of left bracket L right bracket, or S gives dot of ID. At this point you will see dot appears before terminals only. This S we have already expanded, this L we have already expanded, L we have already expanded. So at this point we can stop expanding. So this is the closure of this set. Now this set contains 1, 2, 3, 4, 5 elements. There are 5 items in this set. So which means the set GoTo of I0 comma left bracket will be containing 5 items. Consider the following statements. 1. The smallest element in a max heap is always at a leaf node. 2. The second largest element in a max heap is always a child of the root node. 3. A max heap can be constructed from a binary search tree in theta n time. 4. A binary search tree can be constructed from a max heap in theta n time. Which of the above statements are true? So this is a question from data structures regarding max heaps. So we will go through each of these statements and see which of these are true. So statement 1 says the smallest element in a max heap is always at a leaf node. So imagine this statement is false. Let us say the smallest element we have in some internal node like this. In that case it will definitely have children because it is not a leaf node, right? We will have some children, and to satisfy the max heap property it should be that this node has to be greater than this node and this node. In that case this has to be greater than both its children, since it is a max heap. But we know this is already the smallest element. So which means we can't find two elements greater than this, two elements smaller than this in order to make it children. So this is never possible. The smallest element always has to be at a leaf node, because if it's at an internal node we can't find any further elements smaller than that in order to make its children. So statement 1 is correct. Statement 2, the second largest element in a max heap is always a child of the root node. Let us say the largest element is 10 and we have so the second largest element is 9, imagine, and let us say 9 doesn't belong to any of these two. These two are the children of the root node. Let us say 10 is the largest element, 9 is the second largest element, and 9 doesn't fall in the children of the root node 10. Now in that case here I need to put some value that is greater than 9, and also it should be less than 10 as well. But we know that 9 is the second largest element. There is only one element greater than 9, that is 10 only, since 9 is the second largest element. So in such a case we can't find another element that is greater than 9 that is also less than 10 in order to be 9's parent and 10's child, which means that such a case is also not possible. The second largest element always has to be a child of the root node. So statement 2 is correct. Now statement 3, a max heap can be constructed from a binary search tree in theta n time. Now this is correct. I will show you the algorithm to do that. Let us say we have a binary search tree like this. Now if I do the in-order traversal of this binary search tree, what I will get is the element 1, 2, 3, 4, 6, 8, 10, 12, 13. This is nothing but the sorted order of these numbers. Now in-order traversal of a binary search tree can be done in theta n time. How we do is that using recursion we call in-order traversal of left subtree, print the root node, and in-order traversal of right subtree. In that way if you see each node will be traversed exactly once, that will take theta n time. So in-order traversal of a binary search tree will take theta n time, and in-order traversal of a binary search tree will be giving all the elements in the sorted order. Now if I just write it in descending order, that will give me this 13, 12, 10, 8, 6, 4, 3, 2, 1. So from binary search tree we reached here in theta n time. This also will be taking theta n time, so the total will be theta n time only. Now if you take a look here, if I put that in array form, this is nothing but a binary heap given like this: 13, 12 and 10 are its children, 12 children is 8 and 6, 8 children is 2 and 1, 10 children is 4 and 3. So this is nothing but a binary heap. So effectively what we have done here is that from a binary search tree in theta n time we have got a binary heap. You can verify that if I write all the elements in reverse sorted order, it will give us a binary heap only. So I have given you the algorithm to convert a binary search tree to a max heap in theta n time. So statement 3 is also correct. Now statement 4, a binary search tree can be constructed from a max heap in theta n time. Now this statement is wrong. I'll give you an intuition as to why this statement is wrong. So let us say this can be done. Let us say if we have a max heap, we can construct a binary search tree in theta n time. Imagine. So I have a max heap. In theta n time I construct the binary search tree. Okay. Now if I have a binary search tree in theta n time, I can do the in-order traversal and print the elements in the sorted order. So that will also take further theta n time. So the total time will be theta n time in order to write all the elements in sorted order. Which is what I have done here is that from a max heap in theta n time I have written all the elements in sorted order. If I can do this, that is construct the binary search tree from max heap in theta n time. Now what that means is, if this can be done in theta n time, I can sort all the elements in a binary heap, in a max heap in theta n time, right? Now if you know heap sort, you will learn that first what we do is we construct the max heap that takes theta n time, and after that we retrieve each elements one by one, which takes theta log n time, but which takes theta n log n time. So sorting in total takes n log n time. But if we can do this particular thing, if we can construct a binary search tree in theta n time, we can write the elements in sorted order also in theta n time. So effectively we have got a new sorting algorithm that will sort all the elements in an array in theta n time, which is more efficient than n log n. Now we know that is not possible. If you can do that, then you will get some awards or something. So since we don't have an algorithm to sort an array in theta n time that is more efficient than theta n log n, we can say that this statement is false. Because if we can do this, then we have effectively got a new sorting algorithm. Now looking at the options, you will see that options statements 1, 2 and 3 are correct. That is option A. In an RSA crypto system, the value of the public modulus parameter n is 3007. If it is also known that phi of n equal to 2880, where phi denotes Euler's Gaussian function, then the prime factor of n, which is greater than 50, is dash. So this is a question from computer networks regarding RSA crypto systems. Now if you don't know about RSA crypto system, please refer to the video lecture to learn about that first. Now in RSA crypto system, it's given that n is 3007, meaning n can be written as p into q, where p and q are prime numbers, and phi of n will be equal to 2880 given here, where phi of n is nothing but p minus 1 into q minus 1. So this is what we know from the question. Now phi of n is p minus 1 into q minus 1, which we can rewrite as pq minus p plus q plus 1. Now pq is n only, so that will be equal to n minus p plus q plus 1, which means p plus q will be n plus 1 minus phi of n, that is 3007 plus 1 minus 2880, that will be equal to 128. Now we know p into q is 3007, p plus q is 128. Now we can rewrite that as p and q as the roots of the quadratic equation x square minus 128x plus 3007 equal to 0. How I got this is, in this quadratic equation the sum of the roots will be minus b by a, that is 128, and product of the roots will be c by a, that is 3007, which is what we have here, p and q. So in this case the roots of the equation will be p and q. Now the root of the equation we will get as minus b, that is 128, plus or minus root of b square minus 4ac, that is 128 square minus 4 into 3007 divided by 2a, that is 2. That will be equal to 64 plus or minus 33. So we will get two values, 97 and 31. You can verify this from the question as well. 97 into 31 will be equal to 3007 n, and 97 minus 1 into 31 minus 1 will be 96 into 30, that will be equal to 2880. That you can verify. So p and q will be 97 and 31. In the question they were asking the prime factor of n which is greater than 50. There is only one here, that is 97. So the answer will be 97. A relational database contains two tables, student and performance, as shown below. This is student table having 5 rows. This is performance table having 6 rows. The primary key of the student table is roll number. For the performance table, the columns roll number and subject code together forms the primary key. Consider the SQL query given below. Select s.student_name, sum of p.marks from student s, performance p, where p.marks greater than 84, group by s.student_name. The number of rows returned by the above SQL query is dash. So this is a question from DBMS regarding SQL queries. This is a very easy question in fact. So in the SQL query, if you take a look, we are doing from student s, performance p. What this statement does is it will take the cross product of the tables student and performance and name it as s and p. Okay. So student has 5 rows, performance has 6 rows. So the cross product should return 5 into 6, that is 30 rows. On that, we are adding one condition where p.marks is greater than 84. Meaning there is one row in performance that is having a mark less than 84, that is the last row having a mark of 80. Rest all has a mark greater than 84. So this row will be ignored and the rest of the rows will be considered for cross product. So the rest of the rows are 1, 2, 3, 4, 5 and here there are 5. So 5 into 5, 25 rows will be returned by the cross product of this. Now on that we are doing group by student name. Now initially we were returning 25 rows. 25 rows meaning for the first row we are returning 5 rows from this table. For this row also we are returning 5 rows from this table. Similarly for each of these rows in student table we are returning 5 rows from the performance table for cross product. Okay. On that we are doing group by student name. Now if you see there are 5 unique student names. All of these students have different names. So a group by clause, what it will do is it will return only one row for each student, each unique student names. So it will be returning 5 rows for each of these and it is selecting student name. So this column will be returned like this and it will do the sum of marks from performance, p.marks. So effectively what it will be returning is this particular column student name and 5 rows like this and the sum of all of these 5 rows together, 86 plus 95 plus 90 plus 89 plus 92, that will be the same thing returned for each of these 5 rows. So it will be returning student name 5 rows like this and marks which will be the same mark for all the 5 students. So effectively it is returning 5 rows. Now the question was the number of rows returned by the above SQL query. Now the answer is 5. Assume that in a certain computer the virtual addresses are 64 bits long and the physical addresses are 48 bit long. The memory is word addressable. The page size is 8 kilobyte and the word size is 4 bytes. The translation look-aside buffer TLB in the address translation path has 128 valid entries. At most how many distinct virtual addresses can be translated without any TLB miss? 4 options are given here. So this is a question coming from operating systems topic regarding TLBs, paging, etc. So if you don't understand these concepts, please refer to the video lectures to learn about TLB, virtual address, etc. and then come back to the question. So in the question they have given us that the TLB has 128 entries. Now each entry will be pointing to one page in memory, meaning we can refer to 2 power 7 pages at the same time using the entries in TLB. Now size of each page is 8 kilobyte. Therefore the number of words in page will be equal to 8 kilobyte divided by 4 byte. Word size was 4 byte. That will be equal to 2k or 2 power 11. Therefore the total number of words will be 2 power 7, that is what we got from here, 2 power 7 pages, into 2 power 11, that will be equal to 2 power 8 into 2 power 10, that is 256 into 2 power 10. Looking at options, that is option D. Consider the following 4 processes with arrival times and their length of CPU bursts in milliseconds as shown below. Process P1, P2, P3, P4 having arrival times 0, 1, 3 and 4 and CPU burst time 3, 1, 3 and Z. The processes are run on a single processor using preemptive shortest remaining time first scheduling algorithm. If the average waiting time of the process is 1 millisecond, the value of Z is dash. So this is a question from operating systems regarding process scheduling. Now in this question what we are doing is we are scheduling these processes using preemptive shortest remaining time first scheduling algorithm. In preemptive shortest remaining time scheduling algorithm, what we do is from among the processes we will choose the one which has the shortest remaining time, and we'll allocate that to the processor. We'll give the processor to that process and we'll run that process. Now while we are running some process, if some new process comes in and if that has a shortest remaining time even smaller than the currently running one, then we'll allocate the processor to the new process which came in just now. We'll run that, and after it finishes we'll give it back to some other process. Now based on that information, let us look at how these processes will be scheduled. So initially at time 0 we have only process P1, so we'll run that. At time 1 process P2 arrives, and if you see the remaining time for P1 is, P1 had a total burst time of 3 millisecond, the remaining time is 2 millisecond, but P2 has a remaining time of 1 millisecond which is less than 2. So immediately P2 will get the processor, so P2 will be running. At time 2 nothing happens. At time 2 actually what happens is P2 will be finished executing. Now P2, since P2 had only 1 millisecond, so P2 will finish. At that time there is only one process left, that is P1, so P1 will start running from 2 to 3. At time 3 process P3 arrives, and P3 had a remaining time of 3 millisecond which is actually which is greater than whatever P1 had. P1 ran from 0 to 1 and 2 to 3, meaning P1 ran for 2 milliseconds. It had a total burst time of 3 milliseconds, so the remaining time for P1 is only 1 millisecond. That is less than the remaining time for P3, which is 3. So at time 3 also P1 will keep on running till time 4. At this point P4 arrives. At this point P1 would have finished executing because P1 ran for 3 milliseconds. P2 also finished executing because P2 only had 1 millisecond, and that also is done. Now only P3 and P4 are remaining. P3 has 3 milliseconds remaining, P4 has Z milliseconds remaining. Now currently let us find out what the average waiting time is. P1 waited for only 1 millisecond when P2 was running. P2 didn't wait for any time because whenever P2 came, immediately P2 was running. So wait time of P1 equal to 1, P2 equal to 0, and these two is fixed because both of these have finished running. The current waiting time of P3 is 1 millisecond. P3 arrived at time 3. From 3 to 4 P1 was running, so P3 waited for 1 millisecond so far. P4 just came in, so P4 has waited for 0 milliseconds so far. Now these two processes are not yet finished, so these two's value will change. Now the current average waiting time is 1 plus 1, 2 divided by 4, that is 0.5 milliseconds only. Now in the question it's given that the average waiting time of the process is 1 millisecond. So somehow we need to make it 1 millisecond. Currently all the processes together has only waited for 2 milliseconds. If they wait for 4 milliseconds in total, then only the average waiting time will be 4 by 4 equal to 1. So we need to make them wait for 4 milliseconds combined. P1 and P2 is fixed. P3 and P4 will change. So somehow we need to add 2 millisecond waiting time to process P3 and P4. Now at this point we have two options. Either we can run the process P3 or the process P4. If process P3 is running immediately, it will mean that the Z value is at least equal to 3. Only then P3 will get that time slot because it is shortest remaining time for scheduling algorithm. So if P3 runs immediately, P4's burst time Z should be at least equal to 3. But if P3 runs, P3 will keep on running for 3 milliseconds, and after that P4 will be running. So to P4 we will be adding an additional wait time of 3 milliseconds if P3 is running immediately. If that happens, then the total wait time would be 1 plus 1 plus 3, which added for while P3 was running, P4 was waiting. So total will be 1 plus 1 plus 3, that is 5 by 3, that will be equal to greater than 1. 5 by 4, that is 1.25, that is greater than 1 in the question. So if P3 is running immediately, then the average waiting time will be greater than or equal to 1 millisecond, which means P4 has to run immediately. So P4 will be running for some time, and then P3 will be running. So for whatever time P4 runs, that will be added to the waiting time of P3. Now we know we had to add a waiting time of only 2 milliseconds, right? So P4 should be running for 2 milliseconds only, which means Z should be equal to 2. When that happens, P4 will run from 4 to 6 when Z is 2. P4 runs, and after that P3 runs from 6 to 9. Then the waiting time of P4 would be 0. P3 would be additional 2 seconds added here. So total will be 2 plus 1 plus 1, that is 4 by 4, that will be equal to 1, which is given in the question, 1 millisecond average waiting time. So Z should be 2. Let T be a full binary tree with 8 leaves. Suppose two leaves A and B of T are chosen uniformly and independently at random. The expected value of the distance between A and B in T, i.e. the number of edges in the unique path between A and B, is dash. So this is a question from data structures. Here they are giving us a tree T, which is a full binary tree with 8 leaves. A full binary tree with 8 leaves will look like this. It will be, this particular tree is full and it has 1, 2, 3, 4, 5, 6, 7, 8 leaves here. Now they are saying suppose two leaves A and B of T are chosen uniformly and independently at random. So this is what you need to give specific note to. Two leaves are chosen uniformly and independently at random. If two leaves are chosen independently at random with uniform probability, it will mean that if we are choosing this particular leaf, let us say we are numbering the leaves 1, 2, 3, 4, 5, 6, 7, 8. In the first try, if I am choosing leaf 1, in the second try I can choose leaf 1 also. Even though they say names two leaves A and B, that doesn't mean A and B are different leaves. Nowhere it is given that. A and B could be the same leaves. So which means in the first try I can choose one of these 8 leaves, and in the second try also I can choose one among these 8 leaves. So there are total number of ways of choosing two leaves is 8 into 8, that is 64 ways of we can choose two leaves, and the two leaves could be the same as well. Now they are asking the expected value of the distance between the two leaf nodes A and B in T is dash. So let us draw one table here. In the left hand side I have given that the first node chosen is 1, 1, 2, 3, 4, 5, 6, 7, 8. The nodes are numbered as 1, 2, 3, 4, 5, 6, 7, 8. Okay. So in the first try, let us say we are choosing the first node as 1. It will have a probability of 1 by 8 because each of these are chosen uniformly. Now let us say the first node chosen is 1. Now the second node, for choosing the second node there are 8 options available. It can be 1 only. The second node is 1 only. In that case the distance from 1 to 1 will be 0 because it is the same node. Now if the second node is 2, then the distance will be from here to here and here to here, that is distance of 2. And if the second node is 3 or 4, the distance will be 1, 2, 3, 4. To 4 also it will be 1, 2, 3, 4. If the second node is 5, 6, 7 or 8, the distance will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 4, 5, 6, 4, 5, 6. So if I am choosing this node, the distance will be 2. If I am choosing any of these nodes, the distance will be 4. If I am choosing any of these nodes, the distance will be 6. If I am choosing one only, the distance will be 0. And all of these are equiprobable. Therefore, the expected distance to the second node will be, in one case we got 0, in one case we got 2, in two cases we got 4. So I am writing 4 plus 4, and in 4 cases we got 6. That is 6 plus 6 plus 6 plus 6. Each of these are equiprobable. So we can just take this value divided by 8 to get the expected distance. That will be 34 by 8, that is equal to 4.25. So if the first node chosen is 1, then the expected distance to the second node will be 4.25. Similarly, if the first node chosen is 2, the distance from 2 to 1 will be 2, written here. 2 to 2 will be 0. 2 to 3 and 4 will be 4, just like the case of 1 here. And from 2 to 5, 6, 7, 8 will be 6 only, that is 4 times 6. Again we got the same expression as above, only 0 and 2 swapped with each other. That is again 34 by 8 or 4.25. Now if the first node chosen is 3, again from 3 to 1 the distance is 4, 3 to 2 also the distance is 4, 3 to 3 the distance is 0, 3 to 4 the distance is 2, and from 3 to 5, 6, 7 and 8 the distance will be 6, just like we got previously. So again we are getting the same expression, that is 4 plus 4 plus 0 plus 2 plus 4 times 6, that is 34 by 8, again 4.25. So as you can see, a pattern is forming here. We are getting the same value for whatever we write. So take any random node. We will have one node, let us say I am choosing this node 5. We will have one node with distance 0, that is the distance from 5 to 5. We will have exactly one node having distance 2, that is that node's sibling. If it is 5, it is 5 sibling, that is 6. And there will be two nodes with distance 4, that is from 5 we have 7 and 8 at distance 4. Now these two nodes are nodes which are not its sibling, but it belongs in the same subtree with respect to the root node. 5, 6, 7 and 8 all belong to the right subtree with respect to the root node. So the distance of 7 and 8 will be 4. Similarly, we will have 4 nodes having distance 6, that is the nodes which belong in a different subtree with respect to that node and the root node. So this is the root node with respect to 5, 1, 2, 3, 4 belong in a separate subtree. If you are taking from the root node, that is the left subtree with respect to root node. 5 was in the right subtree. So there will be 4 nodes like that, which will having a value of 6. That is exactly the same for whatever nodes we choose. Meaning, if the first node is 1, 2, 3, 4, 5, 6, 7 or 8, the expected distance will be 4.25 only. Now the probability of choosing all of these nodes are the same only, that is 1 by 8. So the expected value will be this same only, since probability of all of this is same. So the final expected value will be 4.25 only. That is the answer.
This is a networking question based upon the devices. We have been given that we have to connect 15 machines in a LAN using 8-port Ethernet switches. Assuming that these switches do not have any separate uplink ports, we need to determine the minimum number of switches that would be needed to achieve this task. Now we have a switch having 8 ports. So that would be something like this. 8 ports we are having on every switch, and we need to connect 15 machines on them. So definitely one switch will not work. Let us call this S1, and let us have another switch S2 with 8 similar ports. Now as we can see, we need to connect 15 devices, but these two switches would need to be connected with each other using one port. So this particular port would be used for the connection, and in the remaining ports we can configure the devices. So let us see if we can adjust 15 machines using this. Let us call those machines as M1, M2, M3, M4, M5, M6, M7, and rest of them we can put over here: M8, 9, 10, 11, 12, 13 and 14. But we had to connect 15 machines. So even 2 switches will not work. We will need to go for an additional switch. So let us remove this particular device from here, and let us use this port to connect it with another switch of the same type, calling it S3. One port would be used over here, and these are the remaining 7 ports. Now we have only one device left, because this M4 which we brought down from here, that would be put, let's say, over here, and M14 is done, M15 was left, so that we can connect over here. So only 2 ports out of these 8 ports of this S3 will be used for the devices, and 1 port for the connection. So in total we required 3 switches, because for 15 devices we cannot directly put them upon all the ports. We also need to use one particular port for connection of the switches. Hence in this S1 we have configured 6 machines, here we have 7 machines, and over here we have just 2 of them, in total giving us 15 connections. So for this task we need to use a minimum of 3 switches having 8 ports each. So the answer is 3.
There are n unsorted arrays A1, A2, etc. up to An. Assume that n is odd. Each of A1, A2, An contains n distinct elements. There are no common elements between any 2 arrays. The worst case time complexity of computing the median of medians of A1, A2, etc. up to An is dash. 4 options are given here. So this is a question from algorithms section. In the question they are giving us n arrays A1, A2, A3, etc. up to An. Each of these arrays have n elements. So total number of elements in all the arrays combined together will be equal to n square. There are n square elements in total in all of these arrays, and we need to find out median of each of these elements, and then after that we need to compute the median of the medians of each of these arrays. Now it is said that each of these arrays are unsorted, which means that in order to find the median of array A1, let us say A1 is unsorted, so in order to find the median we need to read every element in A1 at least once. If it was sorted, we could have directly gone to the middle of the array and got the median, but since it is unsorted, at least we will need to read all the elements once, meaning there are total n square elements and we will need to read all of these elements at least once in order to find medians and does the calculation. So complexity has to be at least of n square. So we can directly strike out options A and B. A runs in On and B runs in of n log n. That is not possible because there are n square elements and we need to read all of them at least once. Now options C and D remains. Okay, so if you look at it now, if we are sorting the arrays A1, A2, A3, etc. up to A1, sorting array A1 will take n log n time. So sorting n arrays of size n will take n into n log n time. In that case, see, we'll sort array A1 in n log n time. So after that we'll get the median. Similarly, after n into n log n time, we'll get all of those medians. There will be n medians in total. Additionally, we just need to do n log n steps in order to find the median of that array. Now if you are sorting each of these and finding the median, the total time complexity would be n into n log n. N log n is for sorting each array and finding the median, and n into this because we are doing it for n arrays. If that is the algorithm we are using, it will take n square log n time in order to do this problem. But finding the median of an array, we don't need to sort that array. The median of an array of size n can be found in O n time using the algorithm median of medians. So if you are applying the median of median algorithm, we can find out the median of array A1 or each of the arrays in O n time only. We don't need to sort the array and spend O n log n time in order to get the median. So you can learn about this algorithm here. You can learn about this online or in Wikipedia or somewhere. Please learn about this. So using that algorithm, I can get the median of each of the arrays in O n time. Meaning I can get the median of n arrays in n into O n time, that is O of n square. Plus after that I have n medians, and n medians will form an array, another array of size n. Finding the median of that will again take another O n time. So, but it is O n square plus O n, so that is O n square only, which means that option C is the right answer. Suppose y is distributed uniformly in the open interval 1 to 6. The probability that the polynomial 3x square plus 6xy plus 3y plus 6 has only real roots is rounded off to one decimal place. So this is a question from engineering mathematics. It's given in a tricky way here actually. Here we have this polynomial 3x square plus 6xy plus 3y plus 6, and they are saying that y is distributed uniformly in open interval 1 to 6. Y can take any real value between 1 and 6. Now if that is the case, what is the probability that the polynomial 3x square plus 6xy plus 3y plus 6 has real roots only? Now the polynomial 3x square plus 6xy plus 3y plus 6, we can rewrite it as 3x square plus 6y into x plus 3y plus 6. Now if you see, this is a quadratic equation of the form ax square plus bx plus c, where a is 3, b is 6y and c is 3y plus 6. Now a quadratic equation of this form has real roots only if b square minus 4ac is greater than or equal to 0. So which will mean this equation will have real roots only if b square, that is 6y square, minus 4 into a is 3 into c is 3y plus 6 should be greater than or equal to 0. Rewriting, we will get 36y square should be greater than or equal to 36y plus 72, or 36y square minus 36y minus 72 is greater than or equal to 0. Now simplifying that equation, we will get y square minus y minus 2 should be greater than or equal to 0. Now again what it means is this equation will have real roots if y square minus y minus 2 is greater than or equal to 0. Now to solve for this one, this we can rewrite as y plus 1 into y minus 2 should be greater than or equal to 0. Y plus 1 into y minus 2 should be positive. Now this particular function y plus 1 into y minus 2 will become 0 at points y equal to minus 1 or y equal to 2. So if we map all the values of this function on the number line here, at point minus 1 and plus 2, this function will become 0. If you substitute minus 1, this part will become 0. If you substitute y equal to plus 2, this part will become 0. So at these points, and only at these points, this function will become 0. In rest of the points, this function will be either positive or negative. Also, one more point is that at this point, this function becomes 0, and at this point also this function becomes 0. Meaning, in between these 2 points, this function will be either positive or negative. Similarly, more than this also, it will be either positive or negative only. It won't be both. Similarly, for less than minus 1 also, it will be either positive or negative only. Now we'll find out what the values are here. And also before that, in the question it is given that y is distributed uniformly in the open interval 1 to 6 only. So in this open interval 1 to 6 only, we are worried what value y will take. So from 2 to 6 it will be either positive or negative. Similarly from plus 2 to 1 also it will be either positive or negative. That is the only thing we are trying to find out here. Now let us take some point that is greater than plus 2, that is this part of the number line, and see what value y gets. Let us say y is 3. 3 is on this part of the line. Okay. So at y equal to 3, this function becomes y plus 1 into y minus 2 becomes 4. 3 plus 1, that is 4, into 3 minus 2, that is 1. That is 4 into 1, that is 4. Now that is a positive number, which means that throughout this part of plus 2, this function will be positive only. Meaning from 2 to 6, that's what we are worried about. This function will be positive. Now coming to y equal to 1, that is a point less than plus 2 and greater than minus 1. At this point, the value of the function will be 1 plus 1 into 1 minus 2, that is 2 into minus 1. That is a negative value, which will mean that here to here the function will be negative. Now we are not worried about what the function will take at this point, because we are only concerned about what values it will get between 1 and 6. Now between 1 and 6, we know from 2 to 6 it will be taking positive value, and from 1 to 2 it will be taking negative value. And it was also given that y is distributed uniformly in the open interval. So probability of choosing any particular point is same only compared to any other point. So the probability of choosing a point from 2 to 6, we can take it as the length of this line from 2 to 6 divided by the length of the total line from 1 to 6. The length of the line from 1 to 6 is 5, and it takes positive values in 2 to 6. The length of that line will be 6 minus 2 equal to 4. Therefore the total probability is 4 by 5, or 0.8. 0.8 is the answer to this question. Consider the following C program. A program is given here. The output of the above C program is dash. So for the C program, we need to find out what would be the output, that is what is printed by the printf statement, printing sum here. So we'll go through each of the statements and find out what the output is. So initially we are declaring an array A of size 5 here with values 2, 4, 6, 8 and 10. So the array's value would be 2, 4, 6, 8 and 10, and the pointer A would be pointing to the starting of this array, that is A will be pointing to the address of the element, the first element in the array. Okay, and then we have another pointer B that's equal to A plus 4. Now if A points to this address, A plus 1 would point to this address, A plus 2 would point to this address, A plus 3 would point to this address, and A plus 4 would point to this address. So essentially B is a pointer pointing to this element 10 in the array. Okay, now here we are doing for int I equal to 0, I less than 5, I plus plus, we are taking sum equal to sum plus star of B minus I minus star of B minus I. Now star of B will always return whatever is the value in the array location pointed to by the pointer B. So initially B is pointing to this location, that is this element 10. So star of B will be returning the value inside this cell, that is nothing but 10. Star of B will be returning 10, and B minus I will be depending on I's value. It will be pointing to some location somewhere inside this array depending on I's value, and then star will be returning the value inside whichever cell B is pointing to, or B minus I is pointing to. So we'll go through these one by one. Here I have written a table here. I changes from 0, 1, 2, 3, 4. In that case, star of B, no way we are modifying the pointer B, which means star of B will always be returning what is stored here, that is 10. Star of B will always be returning 10. Now star of B minus I will be returning, initially I is 0, so that will be 10. When I is 1, it will be 10 minus 1, 9. Similarly, it will be 8 here, 7 here and 6 here. Okay. Now star of B minus I. Initially I is 0, so it will be pointing to this location. So star of B minus I will be returning 10. When I is 1, B minus I is a pointer pointing here, and the star of that will be the value inside this cell, that is 8. When I is 2, it will be pointing to this cell here, and star of that will return the value inside this cell, that is 6. Similarly, the star of b minus I will be 10, 8, 6, 4 and 2 in each of the iterations. Now we will try to find out what the sum value would be. Initially sum is 0. Sum is 0 when we are starting. To the sum we are adding star of b minus I minus star of b minus I, that is whatever in this column minus whatever is in this column. So initially it was 0, 10 minus 10 is 0, so the new value would be 0 plus 0, that will be 0 only. So the sum changes from 0 to 0. Coming here, the sum is 0 now. To that we will be adding 9 minus 8, that is 1, meaning the sum changes from 0 to 1. Now the new sum is 1. Now here the sum is 1 now. To that we will be adding 8 minus 6, that will be 1 plus 8 minus 6 is 2, that is 1 plus 3, so the new sum will be 3. Here the current sum is 3. To that we will be adding 7 minus 4, that is 3, so 3 plus 3 will be 6. Similarly here current sum is 6. To that we will be adding 6 minus 2, that is 4, so 6 plus 4 will be 10. So this will be the final value of sum, and that is what we are printing here. So the output of the program is 10. Let the set of functional dependencies f equal to qr gives s, r gives p, s gives q hold on a relation schema x equal to pqrs. X is not in BCNF. Suppose x is decomposed into two schemas y and z, where y equal to pr and z equal to qrs. Consider the two statements below. 1. Both y and z are in BCNF. 2. Decomposition of x into y and z is dependency preserving and lossless. Which of the above statements is or are correct? 4 options are given. So this is a question from DBMS topic regarding normal forms and functional dependencies, etc. So if you don't understand all of this, please refer to the video lectures to learn more about those. Now let us take a look at the two new schemas, y equal to pr and z equal to qrs. Now looking at the functional dependencies, clearly r gives p holds in y, because this consists of p and r, and this functional dependency r gives p holds here. Similarly, if you look at z qrs, the functional dependencies qr gives s is there and s gives q will also hold in these two. So all three functional dependencies hold in a combination of y and z. Now let us see if y is in BCNF. A schema is in BCNF if every functional dependency is of the form super key to something else. Now in this schema, r is the super key because r gives p and r is only two columns here. So r is the super key, r gives p satisfies super key to something else condition. So this is in BCNF. Looking at z, you can see r is not there on the right side, so the super key definitely has to contain r because there is no other production that will produce r. So r has to be there. If we take q and r, you can see qr gives s, so that is complete. qrs can give all the three q, r and s here. Similarly, if we take sr only, s will give q, so that will also give everything q, r and s. So qr and sr are the super keys in this schema z. Now if you take a look at this particular functional dependency, s gives q, clearly s is not super key, it is a partial key. So we can't say that z is in BCNF. Z is not in BCNF. So saying that statement 1, both y and z are in BCNF is false. Now looking at statement 2, decomposition of x into y and z is dependency preserving and lossless. So clearly it is dependency preserving because all the dependencies 1, 2 and 3 hold in this schema, and only 3 dependencies were given initially. So this is dependency preserving. Now is it lossless? If we are decomposing one particular schema into two tables like this, then this will be lossless if the common attribute is a super key in one of those schemas. So if you take a look here, the common attribute is r is there in y as well as r is there in z, and r is a primary key in this particular schema y because r will give p. Therefore it satisfies the condition for lossless. R is the common attribute, that is a primary key in schema y, meaning when we are combining y and z together in order to get back or initial schema X, that will be lossless as well. So statement 2, decomposition of X and Y is dependency preserving and lossless is correct. Looking at the options, that is option C, 2 only.
This is a discrete mathematics question. We have been given a first order predicate formula, which is for all X, for all Z's, if Z divides X, this pipeline symbol is denoting division operation. Z divides X implies that either Z equal to X or Z equal to 1, which means if any number is dividing X, then it will either be X itself or it will be 1. So this particular part simply implies that X is a prime number. Now coming to the second part, this part 1 is implying that there exists a W such that W is greater than X, and for all Z, if Z divides W, then either W will be equal to Z or Z will be 1. Now this part is again implying that W is also a prime number. So combining both the parts together, it is simply saying that if X is a prime number, then there exists a W such that W will be greater than X and W will also be a prime number. So we can further simplify it to say that for a given domain, if there is a prime number X, then there will also exist another prime number W such that W is greater than X. Now, given these three sets, we need to check if the given predicate logic is satisfied by them or not. Now, looking at the set S1, it is a set of first 100 natural numbers. Within this set, we have in total 25 prime numbers, but if we pick up, let us say, a prime number 97, then we do not have any greater prime number than 97 which falls within the same range, because the next prime number which we have after 97 is definitely greater than 100. So we can say that this set S1 fails this predicate logic. But checking for the set S2, which is a set of all positive integers, here we can definitely find a greater prime number for any given number, because this set is infinite set. It is countably infinite. So for any given number, we can definitely find a greater number which is also prime. And same applies for the set 3, which is a set of all integers. Here we can do the same thing for negative numbers, and we can do the same thing for positive numbers as well. So for any given number, we can definitely find the next greater prime number. Hence, both these S2 and S3 are satisfying the predicate formula, and hence we can go with the option C, which is S2 and S3. So that is the correct answer.
This was a question from computer organization topic regarding reading from caches. Now the question text was very large, so I have written the summary of the question here. To refer to the full question text, please refer to the question paper itself. Now the question I will explain here. In the question, they were giving us a single level cache, okay, and the size of the cache block is 8 words, and the size of one word is 4 bytes, and the CPU clock frequency is 60 megahertz. So in order to service a cache miss, the processor takes 1 cycle to accept the starting address of the block. It takes 3 cycles to fetch all 8 words of the block, and afterwards it will transmit words of the block at 1 word per cycle rate. What is the maximum bandwidth for a series of read operations? Dash into 10 power 6 bytes per second. What this is, that's what we need to answer here. So in this cache organization, they are saying that in order to service a cache miss, first it will take 1 cycle in order to accept the starting address of the block, and after that it will take 3 cycles to fetch all the 8 words of the block, and then afterwards it will transmit the words of the block at 1 word per cycle. So in order to transmit one cache block, what it will take is 1 cycle first, that is accepting the starting address of the block of the cache block, 3 cycles in order to fetch all the 8 words of the blocks, and after that additional 8 cycle. 8 is for transmitting words of the block at 1 word per cycle. So it will take 1 cycle per word. A cache block has 8 words, so it will take total 8 cycles in order to transmit all the words. So if you see, it takes a total of 12 cycles for 8 words. 8 words because there were 8 words in one cache block, which means it will take 32. It will take 12 cycles to transmit 32 bytes, because one word was 4 byte. Therefore, 8 word size will be 32 bytes. So in 12 clock cycle we can transmit 32 byte, which means bytes we can transmit in one clock cycle is 32 by 12. So that's the average. So in 32 by 12 bytes is what we can transmit on an average in one clock cycle. Now the frequency is given as 60 megahertz, which means in 1 second there will be 60 into 10 power 6 clock cycles in that CPU. So if this is the data that is transferred in one clock cycle, so the data that will be transferred in 1 second will be the data transferred in one clock cycle multiplied by how many clock cycles are there in 1 second, that is 60 into 10 power 6, and bytes per second, that is the data that will be transmitted. So this is nothing but 160 into 10 power minus 6 bytes per second. They were asking how many into 10 power 6 bytes per second we could transmit. The answer is 160.
This question is based upon TOC. We have been given these 4 sets and we need to determine which of these sets are uncountable. Looking at set S1, it is a set of all recursively enumerable languages over the alphabet 0, 1. Now if we have the alphabet set sigma as 0, 1, then the language would be sigma star, and we know that this language is countable. And now we also know that every Turing machine will have a unique binary encoding. Since we have the language 0, 1, we shall have a unique binary encoding for every valid Turing machine. So based upon these facts, since we have the recursively enumerable languages and all of these languages have a corresponding Turing machine to them, so if Turing machines are countable, then the set of recursively enumerable languages will also be countable. Hence this set S1 is also countable, just because of the fact that we have a corresponding Turing machine having a unique binary encoding, and that is a countable language. Hence the set becomes countable as well. Now looking at the set S2, it is a set of all syntactically valid C programs. Now here also same logic applies, that all the syntactically valid C programs have a mapping with a unique binary encoded Turing machine. We can map every valid C program with a corresponding Turing machine, and we just saw that a set of all Turing machines is countable. So again this set S2 becomes countable. Now this set S3 is the set of all languages over the alphabet 0, 1. Now if we have a set of all languages, then that would become 2 to the power sigma star. We know that this sigma star is a countable set, but hence since it is raised to the power of 2, this 2 to the power sigma star will become an uncountable set, because a power set of an infinite set is also uncountable. Hence the set S3 is uncountable. So that would be one of our answer. And now looking at the set S4, it is a set of all non-regular languages over the alphabet 0, 1. Now we know that the set of regular languages is countable and set of all languages is uncountable. So if we want a set of non-regular languages, that would mean taking out these regular languages from all possible languages, which means from this uncountable set we are taking out some countable part out of it. So the set of all non-regular languages would still be uncountable. So that would also be a part of our answer. Hence we got the sets S3 and S4 both to be uncountable, while S1 and S2 are countable. Hence, since we have been asked one countable set, we would go with option B, which is S3 and S4. Both of them are uncountable sets. This is a compiler design question based upon SDT. We have been given the following grammar and the semantic actions. These x1 to x6 are the unknowns. They are the placeholders which we need to find the values of, and the attributes are given to be of the inherited types. We basically have two types of attributes, synthesized and inherited. In inherited attributes, we can inherit the value either from the parent or the left sibling. So based upon this, let us try to figure out what these unknown values can be. In this particular production, D derives TL, x1 dot type equal to x2 dot type. So over here we can determine the value of this L using its parent or its left sibling. So the value of x1 can be L, and the value of x2 can either be D or T. Or another option we have is we can determine the value of T using the value of d. So we can also have x1 equal to t and x2 equal to d. That is also possibility with t taking the value, inheriting the value from its parent d. So both of these are possible cases. Now looking over here, we have no unknown over here. T is having the type of int, t is having a type float. Now over here, x3 dot type equal to x4 dot type. So here only one possibility is there, that this L1 is deriving the value, the type, from its parent L. So this x3 can be L1, which is inheriting the type from its parent, means x4 has to be L. So that is the only possibility over here. And this x5 can be L1 again. We are not concerned with it since we are asked only for the values of x1 to x4. So x3 will definitely be L1, x4 will be L, and for x1 and x2 we are having choices. What are the possible solutions? That this is L, this is T, this is L, this is T, and this is T, this is D, for the same values of x3 and x4. So these three are the valid combinations, and out of these we can see that over here we are having L and T, L1 and L. So yes, this is the matching choice we are having. This T and L is not allowed, L and L is not allowed, T and L is not allowed. So all the others are rejected. Only option A is the correct choice we got, matching to our second option, L, T, L1 and L. So this is the correct answer.
Which of the following languages over sigma equal to a comma b is not context free? 4 options are given here. So this is a question from theory of computation topic regarding context free languages. We'll go through each of the options one by one and see which among these is not context free. Option A, W reverse. Now this is clearly a context free language. We can create a non-deterministic push down automata for this language and then verify all the strings belonging to this language. How we do is, initially we'll be pushing all the alphabets A or B we see to the stack, and at each point we will start popping off alphabets from the stack depending on the input we see, to match that each element on the top of the stack is same as the one we see in the input. We can design a non-deterministic push down automata which does that. So this is a context free language. Now look at option C, that says a power n b power I, such that I belongs to n, 3n or 5n. So this is nothing but accepting the language a power n b power n, or a power n b power 3n, or a power n b power 5n. Now we can create push down automatas for either of these, a power n, b power n. We can easily do push all the a's, and then when we see b's, pop off each a for each b. Or this also we can do push 3a. For each a we see, push 3 a's to the stack, and after that for each b we see, pop 1 a from the stack. So we can do this also. Similarly, this also we can do push 5 a's for each a we see in the input to the stack, and then on seeing each b we will be popping off 1 a from the stack. So these three are context free, and the union of 3 context free languages is always a context free language. So this is also a context free language. Now coming to D, W a power n b power n w reverse. This is also context free. How we do is, we will be pushing w to the stack, the string w to the stack initially. After that we will be pushing n a's to the stack. After that, when we are seeing b's, we will be popping off each a one by one from the stack to match it with b's. So this part and this part we will be matching. After that, we have the string w in the stack, we will be matching it with w reverse. When we see input, we'll verify that each alphabet we see, that is same as the one on the top of the stack. When we do matching and popping off like that, we'll be matching w to w reverse. So for this also we can design a non-deterministic push down automata. Now coming to B, that's only option left. This is not a context free language. Why this is not context free language? We have to match this w to w reverse. That we can do. We have to match a power n to b power n. That also we can do. But we can't match w a power n to w reverse and b power n. Why the case is, that is, we see, for matching w to w reverse we need to push all w's. In order to match a power n to b power n, we need to push all a's to the stack. Now the stack will contain w and a power n. After that we are seeing W reverse. Now W reverse we need to match it with W's. But the stack will have all the A's on top of the string W. Now either we need to remove all this in order to match this. But if you remove all this, we can't later add it back in order to compare it this way. So there is no way we can do this matching using a single stack. So this is not context free. So in the question they were asking which of the languages are not context free. So the answer is B.
This is a C programming question. We have been given a code and we need to determine the output printed by this code. Now let us look at this main function, which is having a for loop in which the initialization step, condition step and the increment decrement step are all a function call to this particular function. Hence this for loop will run as long as the condition is satisfied, which means the value returned by this particular function is positive. Once it becomes 0, then we will break out of this loop. Now one more thing we must understand about the execution of for loop is that in the first iteration, this initialization step is done. After that we check if the condition is satisfied or not. If yes, then we enter the loop and perform this print statement. After that we do the increment or decrement operation and then we enter the second iteration in which we will again check this condition. If it is satisfied, we will go to the print statement and this cycle continues. We will check the condition, print, increment or decrement. Again check, print, do the same. So this is how the execution works. Now let us look at this function R. What it is doing, it is having a static variable int num initialized to 7 and what it is returning, num minus minus, which means the value of num with post decrement to it. So for the first time, let us take this for loop over here, condition and increment decrement operation. Alright, and here we are having a print statement which is again having a function call to the same function R. Now in step 1, over here, when this first function call is performed, the value returned will be 7. It is returning the same value and after returning it is doing this post decrement. So in the next iteration it will be treated as 6 and since it is a static variable it will not be initialized again and again. The same value will be continued. So okay, after initialization in step 2 we come over here, again we make a function call to check the condition and this time it will return 6. Alright, so after this condition is satisfied we will go to this print statement. We again make a function call and this time it will return 5 and we will print that to the screen. Okay, after this was the third function call. Then this will be the fourth function call over here. During increment or decrement operation, this function call will return the value 4. After that, we will go for the fifth call over here to again check the condition. This time the value returned will be 3. And for the next call, we shall come over here, sixth call. This call will return the value 2, which will also be printed. Now the seventh call will be over here in the increment decrement, that will return the value 1. Then the eighth call will be over here for checking the condition and this time the value returned will be 0. Now since the value has been returned as 0, so we will break off, the condition is no more satisfied and the final output we got is just 52. We are out of the loop now and no more functions call will be made. So the output we got on the screen is 52. So that is our answer.
Suppose that in an IP over Ethernet network, a machine wishes to find the MAC address of another machine Y in its subnet. Which one of the following techniques can be used for this? A. X sends an ARP request packet to the local gateway's IP address, which then finds the MAC address of Y and sends to X. B. X sends an ARP request packet with broadcast IP address in its local subnet. C. X sends an ARP request packet to the local gateway's MAC address, which then finds the MAC address of Y and sends to X. D. X sends an ARP request packet with broadcast MAC address in its local subnet. So this is a question from computer networks regarding ARP or address resolution protocol. Now, ARP is used when some machine X knows the IP address of another machine Y in its subnet, but it doesn't know its MAC address. In order to send packets to a machine directly in the local subnet, X needs to know the MAC address of Y, but currently it doesn't know the MAC address of Y. So in order to get that, it uses a protocol called ARP within its local subnet. To learn more about ARP, please refer to the video lectures. Now, how ARP works is the machine X will be sending a broadcast ARP request packet throughout its subnet. What it will be using is broadcast MAC address. So X will be sending broadcast message to all the machines in its subnet. So let us say W, Y and Z are there in its local subnet. So that broadcast message will be received by W, Y and Z. All three will receive it. Now in that it is saying who has the MAC address corresponding this particular IP address. That's what X is asking. Now W will look at the IP address and see it is not its IP address. Z also will see and it will see that is not its IP address. Only Y will see that X is asking about Y's IP address. So Y will reply back, hey, this is my MAC address. That will be the ARP response. So X will be broadcasting this message throughout its subnet and only Y will be replying back. That's how X will get back Y's MAC address. Now for that what X does is it will be sending a broadcast message with broadcast MAC. That is option D. X sends an ARP request packet with broadcast MAC address in its local subnet. The answer is D here. Consider the following matrix R given here. The absolute value of the product of eigenvalues of R is dash. This is a question from linear algebra. They are given us this particular matrix R and we need to find out the product of eigenvalues of the matrix R, the absolute value of the product. Now if a matrix is given, the product of the eigenvalues of that matrix will be equal to the determinant of the matrix. This is a property which we learn in linear algebra. Also, one more property, the determinant of any triangular matrix will be equal to the product of its diagonal elements. So, in order to find the product of the eigenvalues of this matrix R, we just need to find out the determinant of this matrix. Now, in this way, to find out the determinant of this matrix is pretty tough. We have to do a lot of calculations. But if we can do elementary transformation and convert this matrix to an upper triangular or lower triangular matrix, then finding out the determinant is pretty easy. We just need to take the product of the main diagonal elements. Now that's what I am trying to do here. So we are applying elementary transformation. We are doing R2 equal to R2 minus R1, R3 transforms to R3 minus R1, R4 transforms to R4 minus R1. These are all rows which will become this particular matrix here. This 1 minus 1 is 0, 3 minus 2 is 1, 9 minus 4 is 5, 27 minus 8 is 19. Similarly, we are doing it for row 3 and 4 as well. We get this matrix. Now we have made all these elements 0. Now I need to make these two elements 0. I am trying to transform it to an upper triangular matrix. So now we will try to make these two elements 0. For that we just need to do R3 equal to R3 minus 2R2 and R4 equals R4 minus 3R2. Now that will become this matrix. We have got these three elements 0. These elements are also 0. Now to make it an upper triangular matrix, we just need to make this element 6 equal to 0. Now this is 6, this is 2. So if we subtract if we make row 4 equal to row 4 minus 3 times row 2, now this element will also become 0. Then we get this matrix. Now this is an upper triangular matrix. In order to get the determinant, we just need to take the product of the diagonal elements, that is 1 into 1 into 2 into 6, that is 12. Now the determinant of this matrix is 12, so the determinant of this matrix will also be 12. So the product of the eigenvalues of this matrix is just the determinant, that is 12. That's what is asked in the question. 12 is the answer here.
This is a C programming question. We have been given a code snippet for a function called convert, which is taking an integer n as an argument and performing some computations based upon whether it is negative or positive. What they are asking us is which of the following events will happen if this function convert is called with any positive integer n as an argument. So let us take some value of n, let us say 12, and let us see what happens for that. Let us denote this function call convert as this way, c of 12. Then how will it proceed is, it will go to the else case because n is greater than 0. It will call the function convert for n by 2, which means for 6. And after coming, it will print the value 12 modulo 2, which will be 0. For this 6, again the call will be made for 3, value printed will be 0. For this 3, call will be made for 1, value printed will be 1. For this 1, call will be made for 0, value printed will be 1. For this 0, again the call will be made for 0, value printed will be 0. And now this will continue because 0 divided by 2 will keep on giving us 0 and this will never terminate. So actually there is no base case. We are endlessly going into this infinite recursive loop, and because there is no base case, this will keep on moving and there is no end to it. It will never terminate and no value will be printed on the screen. So the correct option will be D. It will not print anything and it will not terminate. If it would have terminated at 0, then it would have given us a binary representation of 12, something like this: 0 1 1 0 0. This is the binary representation of 12. But since it did not terminate at any point, nothing will be printed, and hence the option D will be our correct answer. This is an operating systems question based upon file organization. We have unit style inodes in a file system which is having 12 direct, 1 singly indirect and 1 doubly indirect type of pointers. And the block size in this file system is 4 KB, or we can write that as 2 to the power 12 bytes. The disk block address, or we can say the pointer size, equal to 32 bits or 2 square bytes. So with this, we can find out the number of blocks which the pointers which a particular block can hold. That will be given by the block size upon pointer size. That will be 2 to the power 12 minus 2 equal to 2 to the power 10. So each block will have 2 to the power 10 or 1024 pointers. But now since we are having 12 direct plus 1 singly indirect, which means one entire block with 2 to the power 10 or 1024 pointers, and we are having one doubly indirect, which means we will be having one block in which each of these pointers will be pointing to other blocks. So the total number of pointers this will constitute, that will be 1024 into 1024. So this gives us a value which is 1049612. Now we actually wanted to find the maximum possible file size, and what we got over here is the total number of pointers. But now if this is the number of blocks that are being pointed and each block is having a size of 4 KB, then the total size will be 1049612 into 4, and that gives us a value which is 4198448 kilobytes. Now if we convert this into GB, that gives us a value which is approximately 4 gigabytes. So this is the maximum possible file size which we can have in this Unix style file system. So our answer is 4. This is an operating systems question. We have been given the snapshot of a system in which there are n concurrent processes such that a process Pi has held xi resources for all I from 1 to n, which means P1 will hold x1 resources, P2 will hold x2 instances, and so on up to Pn holding xn instances of the same resource R. But they have given that there are no additional instances of R left, but each process Pi can additionally request yi instances for its execution. Now we know that with this P1 will request for y1 resources, P2 will request for y2, and so on. Pn will request for yn additional resources. But every process Pi can execute only when it has acquired the total of xi plus yi instances, because xi it has already held and yi it has requested. Once it has this total number of instances, then only it can execute, and after execution it can release those resources back for others to use. Now they have said that there are exactly two processes P and Q such that yp equal to yq equal to 0, which means there are two such processes which do not have any additional resource requirement. They can execute in whatever they have already held, which is xp and xq, and after that they will release these many number of resources xp plus xq into the stream, and then these can be used by the other processes. For example, let us consider P1 and P2 are those resource processes such that y1 and y2 are both 0. So now these P1 and P2 can execute using the total of x1 plus x2 resources, and after completion they will release these for other n-2 processes for executing. But they have asked us for a condition which guarantees that no other process apart from these P and Q must be able to complete its execution. So now what do we mean by this is, if these x1 plus x2 excess resources have been released into the stream for others to use and still they must not be able to complete their execution, which means that this x1 plus x2 must be less than the demand of any of these n-2 processes, which means for all I ranging from 1 to n except these P and Q, these x1 plus x2 value must be less than any yi. So we can see that in the option A, that xp plus xq means the released resources must be less than the minimum requirement of any of these k processes, which such that k is not equal to p and k is not equal to q. That simply implies that for all the processes except these p and q, the released resources must be less than any of their requirement. With this, none of these n-2 processes will be able to complete its execution and only these 2 P and Q will be able to complete. So the correct option would be A. Discrete mathematics as well as theory of computation. They are saying that let sigma be the set of all bijections from the set S1 to set S2 having elements from 1 to 5. So we have these two sets having same number of elements from 1 to 5 and we have bijections between them. What do we mean by bijection? A function which is both 1 1 as well as onto. So from this set S1 to set S2 both having 5 elements, what is the number of bijections we can have? Which means the number of 1 1 and onto functions, those will be 5 factorial or 120, because this 1 will have 5 choices. Let us say it is mapped with this 3. Then next number 2 will have 4 choices. Let us say it got mapped with 5. So similarly, we shall have 5, 4, 3, 2 and 1, and taking their product, we will get 5 factorial or 120. So now let us assume that maximum number of states we will have is 120, and now let us see if we can reduce it any further. Next, we can see that id is denoting the identity function, which means identity of j equal to j. Just a simple identity function as we have in the group theory. Now let this denote a composition on functions for a string x such that x1, x2, xn, which means concatenation of these n strings for all sigma n greater than equal to 0. We have a function defined as pi of x equal to composition of these n strings, which means put in simpler terms, it will be, let us say we have over here 5 factorial or 120 functions. So each of these functions will be mapped to some string. Let us say f1 is mapped to x1, f2 is mapped to x2 and so on up to fn mapped to xn. These are the strings and these are the functions. So if we take the composition of these two functions, let us say f1 composition f2. So this composition will actually mean the concatenation of the strings x1 and x2. So if we take composition of these n strings, then that would mean the concatenation of these n strings. So composition translates to concatenation of these strings. So now if we are having 120 such functions, then we will have 120 states such that each of these states will be mapped to some permutation of the 5 numbers 1, 2, 3, 4 and 5. These are the 5 numbers we are having. So any permutation of them will result into 120 possible states, and if we translate from any two state, let us say state 1 to state 2, if we make a transition like this from any state to any other state, then that would mean taking the concatenation of all those variables. So basically, since we have these 120 different permutations available, so that would be the number of states we will have in the DFA, and it will not be possible to reduce that any further. So the minimum number of states we would need to map this given problem using a DFA would be 120 itself. So the answer is 120.
This is a C programming question here. We have been given a program and they are asking us the number of times the variable sum will be printed is dash. Sum is getting printed here. So we look at the program now. Initially we are assigning sum equal to 0, j is 1, I is 2. While I by j is greater than 0.0625, we make j equal to j plus 1. We are adding sum equal to sum plus I by j and then we are printing sum. So till I by j is greater than 0.0625, sum will keep on getting printed. Now we will calculate how many times I by j is greater than 0.0625. Initially I is 2, j is 1, that was assigned. Now first time we will be checking if I by j is greater than 0.0625, that's a while condition. Okay. So initially we are checking for I by j, 2 is greater than 0.0625. We will go into the loop, we will print this time once. After that we will be making j equal to j plus 1. Okay. So j becomes 2 now. We will come outside the loop. I by j is 1. Again that satisfies the condition. So we will be printing again after coming inside the block. And inside the block we are making j equal to j plus j, that will be 2 plus 2, that becomes 4. I remains the same throughout. So I have written down each time j values change. J changes from 1, 2, 4, 8, 16, 32 etc. It keeps on going. I remains constant at 2 only, and I by j values for each of these I have written. I by j is 2 by 1 initially, that is 2. It will go inside and it will print. Then it is 1, again it will go inside. 0.5, again it will go inside the block and print sum. Then it becomes 0.25, again it will be printed. Then it becomes 0.125, again we will go into the block and it will be printed. After coming out, j becomes 32 and I by j is 0.0625. Now the condition I by j is greater than 0.0625 becomes false. So at this point we will stop the loop. So the number of times sum was printed is 1, 2, 3, 4, 5. The answer is 5 here. Let G be any connected, weighted, undirected graph. Two statements. Statement 1, G has a unique minimum spanning tree if no two edges of G have the same weight. Statement 2, G has a unique minimum spanning tree if for every cut of G there is a unique minimum weight edge crossing the cut. Which of the above statements is or are true? 4 options are given. So this is a question from algorithm section regarding minimum spanning trees. We will go through the statements. Statement 1 says G has a unique minimum spanning tree if no two edges of G have the same weight. Now this statement is true. Why that is true is, if you consider Kruskal's algorithm, what we are doing is we will be sorting all the edges based on their weights and then we will be choosing edges one by one in that manner in order to add to the minimum spanning tree. So when we are doing that, if all the edges have different weights, it will mean that there will finally the Kruskal's algorithm will produce one unique graph only at any point. So we can say that this is true. Statement 2, G has a unique minimum spanning tree if for every cut of G there is a unique minimum weight edge crossing the cut. A cut means dividing a set of vertices into two parts. Let us say these three are the vertices in a graph. Then a cut will mean removing all the edges joining this set of vertices to this set of vertices. These two are the one example of cut which produces a vertices in this set and this set. Now G has a unique minimum spanning tree if for every cut of G there is a unique minimum weight edge crossing the cut. They are saying that for every cut we can take inside G there is a unique minimum weight edge crossing that cut. Now let us say this statement is false and we have two minimum spanning trees given as T1 and T2 here. Let us say this edge E1 belongs to T1 and it doesn't belong to T1. Imagine if T1 and T2 are not equal, there should be at least one edge which is there in T1 that is not there in T2. Only then these two will be different. So I have drawn it as this particular edge E1. That edge is not there in this minimum spanning tree T2. Now if we take cut of vertices based on this particular edge, that is by removing this edge, I will get two set of vertices, that's a tree on this part and a tree on this part. That cut will look like this, what I have drawn here. Now if I remove this, I will get a cut like this. Now in T1 we are using this particular edge E1 in order to connect these two cuts, and in T2 we will be using some other edge in order to connect these two cuts. Okay, In T1 I am using E1 to obtain the minimum spanning tree. In T2 I am obtaining this E2, connecting these two cuts in order to obtain the minimum spanning tree. If T1 and T2 both are the minimum spanning trees, then it will mean that these many edges and these many edges are same for T1 and T2, only E1 and E2 are different. If T1 and T2 are both minimum spanning trees, it will mean that E1 and E2's edge weights should be same. But in the question it was given that for every cut of G there is a unique minimum weight edge crossing the cut. Now that is a contradiction. We got two edges having the same weight, and these two should be minimum as well, which means that this is a contradiction and this has to be false. In this cut, whatever was the unique minimum weight edge, we will be adding that to the minimum spanning tree. If we add any other edge, we will be getting a spanning tree which has a weight greater than minimum. So there can't be two minimum spanning trees if this statement is satisfied. That is, there is a unique minimum weight edge crossing every cut. So statement 2 is also true. Now looking at options, that is both 1 and 2.